This conference will now be recorded.
Uh, okay, everyone, let's get started with the second day of ATAL FDP 2021. First of all, good morning. I hope you all had a sound sleep and are well rested, since you need a sharp mind to grasp the knowledge and of the eminent speakers we have for you. Yesterday, we had three amazing sessions given by Shorab sir, Proshanjit sir, Shoptoshi sir, and Shoptoshi sir, where we were mainly introduced to the concept of data science, what is it, and some related terminologies. We also had a look at market basket analysis and recommendation systems. And finally, we concluded by learning some of the machine learning models we can implement. Uh, So today, as our first lecture speaker, we have Dr. Goutam Bandyopadhyay, sir, who will be speaking on the topic linear model selection and regularization. To talk about Goutam Bandyopadhyay, sir, he is presently the associate professor in the Department of Management Studies in NIT Durgapur, and he has completed his PhD in Management Studies from Jadavpur University. He is FIC-Y and FCMA qualified and also graduate in Operations Research from Operational Society of India. He completed his postgraduate diploma in computer application from Regional Computer Center, Jadavpur University of India. His research works are published in numerous foreign peer-reviewed journals and also Indian peer-reviewed journals. He has successfully guided 13 number of PhD scholars, and his research mainly involves with the financial capital market and portfolio optimization using different soft computing techniques such as fuzzy goal programming, fuzzy time series, different statistical multivariate techniques and optimization techniques like DEA using SPSS, eViews, and Lingo's software, and also by RStudio for big data analysis. Before coming to the academic circle, he had 13 years of experience in consultancy in software field. So I guess Gautam sir, you are already made the presenter of this session. So Gautam sir,
Okay,
before you embark upon your 1.5 lecture hours of lecture, I would like to take the
okay,
opportunity to thank some of our participants for giving their honest feedback. And some of the feedbacks I could notice, and I could come up with one of the feedbacks from Dr. V. Kirthika ma'am, who actually asked us ma'am, sir, since most of the people over here are masters or MTech and PhD scholars, since it would be very helpful for them to discuss about research topics. So if time permits, and it's a humble request, if time permits, then if it is
okay,
possible,
okay,
please
okay, okay,
discuss
okay,
about research topics in this. Thank you, sir.
okay. Thank you so much for your nice introduction. So really, it's my privilege that I like to thank also Professor Pushenji Chaudhary to give me the chance for to this August audience. Okay. So without delay, so I'm going to start my lectures, today's lectures. Okay. Just you tell me this is visible or not.
Yes, sir, visible.
Okay. Okay. So this is my today's topic: linear model selection and regularization. And basically, I'll give this topic based on some statistical concept, and definitely I'll try my level best to give some concept of machine learning. Okay, because it is the data science course. So before going to this detail, so naturally, for any model or any chapter, we need some prerequisite. And since the linear model selection and regularization based on statistics, so that's why these terms are very important. There is the one is the parameter and statistics, one is the descriptive statistics, univariate, bivariate, multivariate. Okay. So, if we So what is the meaning of statistics? That is estimation of population parameter on the basis of sample statistics. So this is very important part. What is parameter and statistics? Parameter is nothing but the characteristics of the population, and statistics is nothing but the characteristics of the sample. Okay. So in most of the cases, not only in the convenient research, also the machine learning research. So we collect the data from maybe the small sample, maybe the big sample, big data from some population, and we don't know the population features or population characteristics, because that is the true population is not known to us. So we have to estimate this true population by the some sample population, sample statistic. Okay, so that's why this parameter and statistics are both important. I'm giving simple example. So if I calculate the mean, so we can, if the population members are all known, so then we can estimate the population mean. And if the population and if the samples observations are known, we can estimate the sample mean. And in most of the cases, the population mean is not known. So we have to estimate these population mean with the help of, if my voice is audible? Hello? Yeah.
Yes, sir. Yes, sir. Yes, sir.
Hello?
It's audible. Hello. Yes, sir. It's audible, sir.
Okay. Okay. So naturally, my problem is the population parameter estimate with the help of sample statistics. So we can estimate population mean with the help of sample mean. We can estimate population standard deviation with the help of sample standard deviation. We can estimate population correlation with the help of sample correlation. Similarly, we can, this is the most important topic for the today's class session, that is the regression coefficient. Okay, so we can estimate the population regression coefficient with the help of sample regression coefficient. Okay. And naturally, this part is very important part. Descriptive statistics, everyone knows that is for when you collect any data. So naturally, from that data, we need some, measures. So what are that is basically called 9-point summary. 9-point summary. So what are the 9-point summary? Now, when you collect some data in same, say, continuous data, so then you can easily, calculate the minimum value of the data, maximum value of the data, Q1, Q2, Q3, as well as the mean, standard deviation, skewness, and kurtosis. So these 9 points are very important for the data analysis. Okay. Now I'm coming to the part. Next, it is the meaning of univariate, bivariate, and multivariate. I'm coming, giving simple example. Say I want to estimate the selling price of the house. So selling price of the house, if we consider a single variable, that is basically univariate variable. So is it possible? So naturally, some selling price of the house are given to me. I will show you some software given to me. So naturally, on the basis of this, we can estimate the mean of the selling price for the future prediction. So then the question will be coming: the selling price. When you got selling price, there are some cause and effect relationship. That is, selling price will depend on some factors. So we can estimate selling price rightly if we know some parameters. Okay, some parameters, we know some variables, attributes, so maybe some features. So in this case, selling price, maybe if we know the size of the house, then we can estimate the selling price. So when you come with the univariate, there is a single variable. Okay, and when price depending on size, there is the concept of bivariate. But now question is, in the real life scenario, mainly we have to deal with the multivariate analysis. That is when we deal with the so many number, more than, say, when you consider one dependent variable, there is outcome or target, this thing, and more than one independent variable, that is the concept of multivariate. That is, in terms of variable and vector. So another analysis is a vector to vector relation. There is more than one dependent variable and more than one independent variable. So that is a concept of multivariate. And in multivariate analysis, there are so many objectives. So definitely I'll discuss that part. And why we need the deterministic and probabilistic? It's mainly mainly everything based on the probabilistic, because we know that or don't know the futures. Okay? So some data set is given, and on the basis of that data set, we have to calculate the future. That is basically random experiment we are doing. And that's why you know the concept of probability. I'm not going in detail. Random variable. And we have to know the concept of probability distribution. This is very, very important part. Some probability distribution, like normal distribution, is the theoretical distribution. And from that theoretical distribution, we derive some sampling distribution, like the T distribution, F distribution, chi-square distribution. So these are all the derived sampling distribution. And very, very important part of not only in convenience statistics, machine learning is the sampling theory. Okay, so that part I will detail explain later on. And this is the basic concept too, which is very, very useful for my today's class. So when you estimate some parameter, then the term is called is unbiased or not. Okay. So already you have some knowledge about the bias variance. So this is the important question is why. So can we estimate the population parameter with the help of sample statistics? I'm giving a simple example. Can you estimate the population mean with the help of sample mean? And if we estimate the population mean with the help of sample mean, that is called the unbiased estimator. Then we can say what is the unbiased estimator of the population mean. So similarly for the standard deviation, can we estimate the population variance with the help of sample variance? Then sample variance will be the unbiased estimator. In this way, correlation and regression coefficient, this is our objective to getting the unbiasedness. And another term is very important. Our objective is to get the minimum variance unbiased estimate. Naturally, estimator must be the minimum variance and that must be unbiased. That is called MBU. And since our topic is to the linear model, so we search for the best linear unbiased estimator. It's called blue. And if these three conditions are satisfied, so then our model is the consistent. Okay. And naturally, in our some estimation, there is some point estimation and some interval estimation. So for some data set, we need some interval, and for some data, we need some point estimation. Okay. For in some case of medical case, we go for the point estimation. Okay. And in some cotton industry, some the shoe industry, so then we can consider the interval estimation. Okay. So this is our basic concept. Now comes to testing of hypothesis, which is very, very useful part of our analysis. That is when you start any type of linear model or any kind of, say, we go for the classification model. Okay, so we need to construct some hypothesis. And hypothesis is divided into two parts. One is a null and alternative. I'm not going in detail that everyone knows. So this is, and on the basis of p-value is very, very important criteria for my today's true session, because p-value is the criteria for entering variable in the model or discarding variable from the model. So that's why it is very important. Not only that, nowadays it's a very interesting term is going on for the data science. There's the p-hacking. P-hacking, because using the p-hacking, we can publish any industry their products in the market. So that is some ethical issue. That part I'm not discussing. So, but p-hacking is very important, which is based on the concept of p-value and confidence interval. Already I told you that is basically the acceptance limit. Okay. Now, before coming to this, I like to show some example. Then we can understand what is the meaning of univariate, bivariate, and multivariate. Okay. Say, I'm taking the help of one open source software. This is called the Jamovi. Okay, this is open source software. Why it is open? What is the importance of Jamovi? The backend is the R. Okay. And I will take this today for the two session class. I will take the help of three softwares. One is the Jamovi and one is the R Studio, and another is the SPSS. Because why? Because SPSS and Jamovi both are the front end. Yeah.
Goutam,
My voice is not coming.
Can you off your camera, because your line is stuck sometimes.
Debating, no?
You mute your camera, okay.
Now it is okay. Now it is okay. Okay, some light is coming, no? Hello?
Yeah.
Okay, now voice is audible.
Yeah, audible now.
No, my voice is audible.
Audible now. Please continue.
Yes, sir, it is audible.
Okay, thank you. So I am like to show you some concept of, the linear model concept. Why we will transform from univariate to bivariate and bivariate to multivariate. That is most important part. Okay. And for this, I will take some example. As a very simple example. This is in the, okay. This is visible, this data set.
Yes, sir.
Okay. Okay. Just need to understand why we need this concept. Say selling price of the house, I have taken only the 10 samples. Okay. And these are the, three independent parameters. So first, I like to show you if we want some relationship between the selling price and size of the house. Already I told you. So that is called the bivariate analysis because we consider only a single independent variable, a single predicting variable. Okay. And what is the problem we'll face? That what I'm showing. So we go to simply regression, and we go to the linear regression. Okay. And automatically, there is some dependent variable and covariates. We consider selling price as a dependent variable and only size is the independent variable. Okay, just to check that this output is coming. It takes time. Output has already come. Just to check, simply this part we get R, that is the multiple the correlation between selling and R square means 0.661. That means only 66.1% of the variation of selling price can be explained by the size. So that means explained part is 66.1% and unexplained is the nearly 33.9%. Okay.
Sir, your voice is
And
breaking a lot.
but this
Can
is
you
the
repeat?
concept of hello. Now it is
Sir,
okay.
sir, your voice is
Hello.
breaking.
Might be some
Sir,
net issue.
little bit break.
From that.
Yes, sir. There is a need issue, I think,
Little
sir. Maybe, sir, you can convert your cable net. Yes, sir.
Now my voice is actually your voice also breaking to me. Okay. Now it is okay.
Yes, sir.
Yeah.
It's okay.
Okay. So now I'm taking okay. I little bit louder. Okay. Sorry. And that's is independent. Just to check here, R square is coming. The 66.1%. Already I told you that is the 66.1% of the variation of the selling price can be explained by the size of the house because selling price depending on the size of the house, but only 66.1% explained. And not only that, on the basis of p-value, we can take the idea that size is the important parameter. Question is why? Because there is a thumb rule. I'm not going in detail because if the p-value is less than 0.05, again repeat, if the p-value is less than 0.05, that implies the independent variable is important. That is a significant value. Okay, significantly. So here, this is a concept of bivariate. So now what is our objective? Not only in the convenient research statistics, in machine learning, our objective is how much we get the more explained part. That means how much our objective is to minimize the error. This is our main objective. So what we do, we call it simply we take the age as another variable. Age as another variable. Just to notice, when we consider age, R square is nicely improved. 91.6% explained. That means age is a very important parameter, and that is the concept of multivariate analysis. Okay, and still there are near to 8.4% explained, 8.8, some nearly 9% not explained. And not only that, size and age, all p values are less than 0.05. So from this result, we can tell that is a size and age as very important parameter to estimate the selling price of the house. Okay. Next part is that I'm going to the next part. Why we need the different types of linear model. So I'll take the help of another software now. Another software, that part I will show you because that part it is not possible to show by the Jamovi. Okay, I will take the software. This is a SPSS software, SPSS. Okay, and same problem I have taken in SPSS. Now, what is our objective? Because what is the the change of the model. Okay, change of the model. So I want to fit a simple linear model with a single variable. Again, repeat. I want to fit a simple linear model. There is one predicting variable with a that is a SP and size. This is my objective. Can I improve this model? This is my question. Can I improve? So what I'll do that, we go to analyze. We go to analyze. So we know the linear model definition, everyone knows that maybe the first degree polynomial, that may be the second degree polynomial, that may be the third degree polynomial, because the coefficient is the linear. Because if we get y equal to mx plus c, the coefficient of x is m. Okay, naturally in the mathematics it is called slope, and naturally in the statistical language it is called the regression coefficient. So I'm coming to the part, say y equal to a plus bx plus cx square. It is also a linear model because a, b, c are the linear in nature. Similarly, third degree polynomial 40. So any kind of polynomial is a linear model. But question is, when you consider the linear model, so when you go for the third degree, fourth degree, so complexity grows, complexity increases. So when the complexity increases, so the question is why? Because it is very difficult to estimate so many parameters like the theta naught, theta 1, theta 2, which are the coefficient of x square and x cube. So that's why I am showing what is the problem we will face. We go to analyze and go to regression and go to curve fitting, curve estimation. Okay. So when you go for, so naturally using SPSS we can fit the 11 model. That is not the thing. So today I will show you only the the linear model concept. Okay. So we consider selling price as a dependent variable and the size of the house as the independent variable. That to understand. And we consider linear model and quadratic model and also cubic model. Okay. So when you consider linear model, quadratic model, and cubic model, then just click OK. Definitely the outputs will come. And this is the outputs. This is the outputs. So nicely, just you check it. When you take the linear model, the R square is 0.661. Okay, it is also linear. Simple model. Linear model is a basically simple model. So when you get the quadratic model, it R square slight change, increase. And when you take the cubic model, R square also changes. So from these three, we can consider this the cubic model is the fit for this data set. Fit for this data set because maximum explained part. Okay. Now, so when you get this idea, okay. So for another, I am taking another example. Then you can easily understand this part also. Okay. Another example I am taking. Open data. So this is a bias. This is very, very interesting part. Very, very interesting part. So I'm telling you what is the why I have taken this example. Say here because I'm doing the research in the share market data, capital market portfolio optimization. So I have taken arbitrarily the 4 stocks. This is called the rate of return. 4 stocks rate of return. That is, I have taken 3 stocks. I'm not giving the names. 3 stocks, and this is a market return. The market return, maybe the Sensex, maybe the NSE, maybe the BSE. Everyone knows. So that is the 3 stocks. So what is our objective? Is there any relation with the stocks with the market? So since there are 3 stocks, so we want to fit some relationship. So how will we fit? So so naturally we need the 3 linear model because stock 1 is the dependent variable and the market is the independent variable. Okay. Then we go for this thing. So regression, linear, and we consider first stock is dependent and market is the independent. Okay, and just click it. So first I'm solving with the stock one. Stock one is the dependent and market is the independent. And click OK. And we get this thing. R square is very less. When R square is very less, that means your error is more. It's only 39% explained. So then you go to this, coefficient. And this coefficient is only, market coefficient is the 0.518. And we know this is the concept of beta. Okay. And not only that, here the significant value is greater than 0.05. So naturally we can say this the market variable is not not significant for predicting these stocks. So there are so many reasons, because I have taken a very small sample. Okay, that is the reason for that. Okay, so that is my objective is to show what is the concept of beta, okay, and what is the concept of this R square. Okay, now I'm coming to this changing the model. So we go to regression, we go to linear. Okay, and we go to I'm going to the analyze and go to for the curve estimation, and we select the dependent variable and the market as the independent, and again we select linear quadratic and cubic. Okay, so when they get the linear quadratic and cubic, we click OK. So what do we get? Just to check, your cubic model is perfectly R square equal to 1. That means error is 0. Simply error is 0, and when error will be 0, so there is a concept of high bias. Okay, that's what I'm coming, and that is in terms of machine learning, it is called the overfitting problem. Okay, so naturally, overfitting problem means all data points on the fitted line. Okay. So now since R square is 1, so one thing I can do that for giving simple analysis. So go to curve estimation and select only because already I have shown the linear part, and quadratic also not the overfitting part, because only 0.565 is explained part. So you go to this, click OK. Then what else? Check that. This just you see, check the figure. This is your observed points, 4 points. I have taken only 4 points, only for understanding. And all 4 points, and this is your third-degree polynomial, and all 4 points on the curve. So that is called the concept of overfitting. And actually, when you study in the real data, so maybe don't get R square equal to 1, maybe R square 0.9, maybe R square 0.96, and then you have to draw the graph, and in the graph you check that maximum observed data falls on the pure fitted line. Okay, so this is the concept of overfitting. Now I'm coming to the part. So obviously for today's lecture, how to avoid this overfitting, this is my today's lecture. Okay, so now I'm coming to the next part. So this is, question is how okay. So now I'm coming to my today's concept, today's lectures, given some basic. So first of all, when you start any kind of linear model, so these 3 questions will be in mind. Okay. First of all, what is this, and why this, and how this? And for any kind of linear model, there are some research questions. Okay. So what are the 3 questions? So first, for explaining what we'll take some example. So what is the example? Like, company wants to know that which promotional component impacts the sales of its products more for the allocating budget accordingly. So naturally, we can consider the different markets. Maybe the 200 markets we can consider. Okay, and for the 200 markets, we can consider what is the selling price, sales of the products. And because sales of the product, depending on these three advertising media, like the TV budget, there are some expenses for the budgets, TV budget, radio budget, also the newspaper budget. And output is the sales of the product. So this is the multivariate analysis. So now what is the research question? So this problem is given. So now on the basis of problem, our objective is to fit a linear model. So for linear model, so definitely there are some research questions. So what are the research questions? Now, is there any relation between sales and advertisement budget? There is any relation between dependent variable and independent variable individually. So that can be solved by the scatter plot. Everyone knows it. Okay. And next question: how strong is the dependent variable? That is, we need the concept of R square and adjusted R square. Okay, how strong is the dependent variable? And next part is the nature of relation. Can I form a mathematical model? And this part, we need mathematical model, divided into basically two parts. One is the linear model, non-linear model. So today discussion on linear model. Okay, so can we form any mathematical model like the linear? Fourth research question is, which media contribute to sales? Contribute to sales means obviously we have to consider the coefficient of the input variables, because there are three media, x1, x2, x3. Okay, so what is the coefficient of x1, what is the coefficient of x2, and what is the coefficient of x3? On the basis of coefficient, we can determine that which media contribute to the sales more or less. And next part is how large is the effect of each media on sales based on standardized coefficient. This is very, very important part, standardized coefficient. In any machine learning technique, before going to form this linear model, you have to standardize or normalize, better to say scaling the data set. This is very, very important, and because it will help you the gradient descent technique, okay, for getting the global minimum. Because we are approaching to the global minimum part, okay. So that is the main issue of the machine learning case. And now the concept is how accurately can we predict the future sales, and that is the machine learning based on bootstrapping. That part I'll discuss. Okay. I'll definitely discuss what is bootstrapping and what are the different cross validation techniques. So, and for doing this, we need some basic concept. That is basically, we need the association based on the covariance, and the covariance matrix based on the mean, and only the mean of x and mean of y. The question is why. This is the x-axis. There is a one x-axis. This is the y-axis. I'm not going in detail. We consider the different observations, different observations on x-axis, different observations on y-axis. Similarly, you can find the combined mean of x. Similarly, you can combine mean of y. And from that combined mean, we can draw the two lines. One is the vertical line and one is the horizontal line. So it divides into four parts of the quadrant. And obviously, this part is the plus, where the xi and yi both are more greater than x bar y bar. So that I'm not going in detail. This is the plus, and x bar y bar is my new origin. Okay. Initially, when you start with the origin, this is called the 0, 0. So anything, this covariance is nothing but the transformation from xy plane to the x minus x bar into y minus y bar plane. So that's why you need some transformation. So this is the very interesting part, because plus means the positive association, minus means positive association because it is a product, and minus plus is the negative association, and plus minus is the negative association. So naturally, when you get the data for the data visualization part, you plot the data in a graph paper. And if you check that your maximum data set lies in the first and third quadrant, so automatically you can give the conclusion that there is some positive association between the two variables. Okay. Now, and problem is, this is basically a simple sample example of covariance matrix. There are four variables. So diagonals are the variance, and the off diagonals are the covariance that and this is the concept of correlation matrix. This is nothing but the transformation, it's a standardization form, because covariance matrix is not the unit free, but the correlation is the unit free, because if we divide this covariance matrix by the standard deviation of x into by standard deviation of y, because correlation value, we get the correlation value. And everyone knows that correlation matrix is a symmetric as well as a covariance matrix. But the problem is what is the advantage of correlation matrix? Because correlation matrix takes a very short value, because we know correlation lies between -1 to +1, so easily we can interpret on the basis of -1 to +1. So that is this conversion is very important. Okay. So this is a basic concept of this linear model. Now I am coming to this my second part, how we predict a model. How you predict a model. So that means in my data set, some values, observed values are given, that is called Y, and naturally some, the independent variables are given, which are called predictor variables. Okay, and that on the basis of predictor variable, we try to build a model, and there is some error because we don't know the true population. Okay, so that means Y divided into two parts, explained part and unexplained part, and this explained part is a function of X, and this is error. So maybe here we have taken Y equals the total population, because if F is not known, so it is estimated by F hat. Okay, so basically here we take the linear model. Okay, but always I am telling you, always the linear model will not give the true picture in the data science. Okay, so naturally in that case we have to consider so many non-linear models. That part today I am not discussing. Okay, so and there is some assumption when you go for linear model. There is some assumption that is error is random, which is the independent of X, and hence the mean. And I'm telling you, so when you deal with this thing, so we get this type of thing, the prediction error. Now, what is the difference between prediction error and explanatory error? Because in the linear model or regression, there is an assumption, there will be no multicollinearity. There will be no multicollinearity. There will be no multicollinearity means there is no high correlation among the independent variables. So there is an assumption. But in most of the real data, most of the data analysis cases, okay, we get the so many multicollinearity occurs. So since the so many multicollinearity occurs, in that case, that error is called the prediction error. And this average prediction error, I know the divided into two parts. That is the average reducible error, and this is called the average irreducible error. That is missing. Sorry, average irreducible error. So this is average reducible error. That but that is on the basis of machine learning concept how we reduce the reducible error, because our objective is to increase the prediction error, minimize the prediction error. So to minimize the prediction error, we have to minimize this residual error, and naturally this irreducible error we can never be minimized. And this reducible error is the two functions. One is the bias and variance. So I'll take another example for giving the concept of bias and variance, and what is I'll give some example. Why, if there is a high bias, then what problem we'll face, and while there is a low bias, then what problem, very low, what problem will face. So naturally, we need a model that is already discussed, a consistent model. When the bias variance, there is a trade-off between bias and variance. So we need the low bias as well as the low variance. So that part I will show with some example. And for doing this, the linear model concept, we need to know the concept of degrees of freedom, concept of R square, concept of adjusted R square. So there is some thumb rule of ANOVA, that what I am not discussing here. Thumb rule of regression, thumb rule, and this is very, very important part. That is the concept of variance inflation factor, and that is basically applicable for multicollinearity part. So naturally, since today I have declared in the next session, I'll discuss about this BIF. Okay, that BIF part, but BIF is very, very important issue for the multicollinearity. But mainly, I'm telling you, we are applying this BIF in case of the short data, small data, maybe 100, 200,000, 2,000. In that case, okay, BIF. But when you go for the large data size, so then we consider another technique for the multicollinearity part, that is the singular value decomposition. That is basically applicable for the data scientist, data science, data analysis. And another is the concept of autocorrelation. This is very, very applicable because when you deal with the linear model, so there are two parts. One is the cross-sectional part, which is independent of time. Another is the longitudinal part, or which is dependent on time. So there is another linear model analysis, time series analysis. So that part I will not cover today. But on this concept of autocorrelation, we can get the idea. Either we will follow the cross-sectional or we will follow the time series. So that's why I have given this concept. Okay. Now, and coming to this machine learning part now, Okay, because up to this the conventional part. So machine learning is a new horizon, and learning from experience, learn from data, and follow instruction. Okay, so that you know everyone. And this is a simple, typical example of regression. Say sales of ice cream depending on temperature. Okay, sales of ice cream depending on temperature, and these are the observed value circle, and this is the fitted line, linear line. And just you think there is so many deviation, that means we can consider this is not a good model. That is basically in the term of statistics, it is called underfitting model. Underfitting model is not a good model. So for the we need the improvement. So naturally, for the improvement, what we'll do that we do go for so many technique of machine learning. We go for the bootstrapping. We go for the the k-fold cross validation. We go for the the loss of the law of the one out cross validation technique. There are so many techniques for the boosting, bagging. So there are so many techniques for improving this. So this is the next improvement. Suppose I am applying some techniques for improvement, we get again linear model. And still there is some difference between the observed and the fitted line. Next we go for another improvement. This is another improvement by training the data. Okay. So this is another improvement. Here the error is less. Here is less, and maximum observations observed on the line. And if we go for this thing, this is called the overfitting. This is called the overfitting. Why? Because it's a curve, it's a complex model. It's a complex model, and naturally maximum observation on the model and only two observations outside the model. So we can say this is a concept of overfitting. The problem of overfitting I am discussing now. So this is the concept of overfitting and underfitting. Now, already I told you that in regression you get this thing. This is the line, and these are the observed points. Already you know this thing. So obviously we can say this is a underfit model. And if we consider this is a model, some observations outside the curve. So we say, okay, more or less not bad. But if you check this is overfitting. And this is the example for regression, and this is for the classification problem. That part I will not discuss today. Okay. So this is the regression part. So there are two cases. One is the underfitting and one is the overfitting problem. So I'm telling you, so when you go for machine learning case, so you divide or you can split your data into two parts. One is the training part and another is the testing part. So there are some ratio in the data science, in the machine learning. Someone can take 70-30, someone can take 2/3, 1/3. Okay, so this is the someone can take 60-40. So that is basically based on domain. I'm telling you, not only that, based on the domain data size. Okay, so after this splitting the data, and you feed the data, you feed the model with the training, and if you check you naturally, when you feed the data with the training, you get some value of R square, and definitely we get some value of residual sum of square, better to say what is the error part. And now, if your error part is less in case of training data, and you check with the testing data, and if you check your the testing data, there is a huge fluctuation. That is, your MSE is very high. That is, error is very high. So that is the cause of overfitting. Question is why? Because we need to know the pattern. Our pattern will be the same for the training as well as the testing. Question is why? When you consider the data set, so overall pattern must be sent throughout the data, and that's why you need some randomization technique. I will show you that part definitely, and that's why we welcome this the regularization technique. So this is the that part is basically theoretical part. Actually, overfitting and underfitting that everyone knows. That is when the training data set variance is very low and bias is very high, and in the testing data set variance is high, bias is so sad. That is the cause of overfitting. That I'm not reading this thing. So this is the cause of overfitting and underfitting. Now, so how you will overcome the problem is the regularization. That is how we solve the regularization technique. Question is why? I'm giving a very simple example. Then you can understand, I hope, what is the concept of regularization. I'm giving a simple example. Then I will go to the detailed part, theoretical part. Say I'm going, in SPSS, okay. Say for SPSS, first I show what is the concept of overfitting. We go to analyze, we go to regression, and we go to linear. So reset. Now we consider the dependent variable. There is a high beta, and market is the independent variable. Okay. What we get and what is the objective of regulation, that what I am showing. Say click OK. When I click OK, then just the thing R square is very high. And your beta value is 3.211. Try to understand. And your market p value is satisfied because p value is less than 0.05. So we can consider also that is some regression is, to some extent regression is valid, though the sample size is very small. So I like to give some concept. Say here the beta value is 3.211. So initially in the simple mathematics, say y is equal to beta naught plus beta 1x. So this is the model, simple linear model. Now what is the meaning of beta 1? That is my question. And how we understand that beta, that why it is called high beta, high bias, and why it is called low bias. Suppose we change the x by 1 unit. Simple, x we change by 1 unit, and this change is called y star. Initial y, and this is the after changing. And actually you already saw the value of beta or beta 1. So what is the meaning? This now we get y star, change of y. What is the beta definition of per unit change of x? What is the change of y? That is the mainly beta. So y star minus y, if we subtract this, we get only beta 1. So that is the beta 1 is nothing but for the change of per unit change of x. What is the change of y? Now I am giving a simple example. If we, what is the problem? Say I have taken two variables. One is the salary along the y-axis, and experience in the x-axis. So we know the salary depending on x-axis, and we have some data points. Data point means we have some salary values, we have some experience values, and we plot the data point in the graph paper, and we get a, say this is the line, and your line equation say y equal to say 1.3, say plus 2x by chance. So definitely after getting the result, we have to explain physically. From my domain is salary and experience. If I work on share market, that is my domain. If I work on marketing, CRM, any business, that is domain. So naturally, when you get some model, we have to explain from the domain. So here the domain is the sales depending on the experience. Salary depending on the experience. Try to understand. So if the salary experience is the 2 years and experience is the 3 years. So for the 2 years salary experience, we get some salary. And when you change 1 year, your salary will be doubled. So definitely, is it not feasible? So that is the cause of overfitting. So what we want, why we need this regularization? Because since it is overfitting, so we have to shrinkage the value. We have to, the shrinkage the value, minimize the value of beta to a point where we get the low bias and low value. You increase the value. So this shrinkage the value is one kind of regularization, and that is named as the ridge regression. So this is one aspect. Another aspect is in the real data side. I know already Bhushanji Chaudhary discussed nicely in the last day class. In maximum data set, we get some sparse item which are not relevant. But how we manage, how we discard that sparse item or the irrelevant item, so that can be solved by the regulation. And that by the lasso techniques, another regulation. That lasso means where it is applicable, where we get the so many variables, but all variables are not important. All not important, because if we consider all variables, we have to consider so many beta values. That what I discussed in the second session. Okay. So naturally you have to consider all so many. So you have to discard some variables. So how we discard? That means some beta values will be 0. Some beta values will be 0 for some variable, so that can be solved by that another regulation technique, which is called the lasso. That part will come in. Another thing is that say our main objective is to shrinkage the beta values, and another objective is to hello.
Yes, sir.
Can I start?
Yes, sir, you are
Yes, sir.
audible.
Yes, just continue.
So, okay. So another thing is that in some cases, say there are so many variables, and some variables we have to shrink. That is, some beta values to be minimized. Okay, from overfitting to the generalized regular fitting, and some variables to be discarded. So how we discard? Naturally, we need some penalty, and that is the concept of machine learning. How we handle this overfitting problem. So that part now I'll discuss how we handle this overfitting problem. So I'll try to give this example by the some example. So, and that I'm telling you, this is the very interesting part. Say somebody's understand the ridge. Ridge basically shrinkage. Ridge basically shrinkage the beta value, and this is the lasso. Lasso gives the the discard the variable. So definitely in between, for some data set, we need ridge and lasso simultaneously, because we need some beta values to shrinkage, and we need some variables to be discarded. So at the same time, so that is solved by the elastic net. So that is the another regulation technique. So that means elastic net is nothing but the convex combination of ridge and lasso. So that part. So this is the main concept, because we have to minimize this bias, because the bias is just you think here the market is coming 3.211. That means if we increase 1 unit of the market index, the stock prices will be double, 3 times. So it is infeasible. It is not feasible. Okay, so that is the completely volatile market. So that part I'm not discussing. Okay. Okay. Now. Okay. So I'm going to this. So 1 minute. Okay. So now this is overfitting already I have told you. So this is the 3 types of regulation technique. This is the form of regression that constant regularize or shrinks, the coefficient estimates towards 0. Already I told you. And in other words, the technique discusses learning a more complex or flexible model so as to avoid the risk of overfitting. That is the main objective, risk of overfitting. And to identify the underlying the data pattern, we split the data into 2 parts, training and testing. And we encounter overfitting within training and testing data. We apply the regulation techniques. Okay. So these are the 3 regulation techniques: ridge, lasso, and elastic net. So this is the regulation graph. Okay, I'm telling this is a very important part. So this is your ordinary least square method. Ordinary least square method, that is the RSS. And in the machine learning technique, why it is L, it is called the loss. because error is treated as a loss, or you can say cost function. Okay, so that is called a loss, that is called RSS. Okay, and this is called the reach. That is when you go for the reach, so that is the RSS, and plus this is the penalty of beta j square. Why reach in the beta j square? I am telling you, very interesting. Our data science, we discuss from data filtering so many techniques, Okay, there are some outliers, you have to avoid outliers, there are some influencing points, there are some leverage, that part is another portion, okay, for the data filtering part. And after that, you come to the data visualization, that is the graphical feature. Then there are for the data mining part, already for the query, different types of query automation, you go for the data mining part. And next part is now I'm discussing before that, that is the predicting part. So how you predicting a model. But after predicting a model, we check that there are so many overfitting occurs. So we need some optimization techniques. And regularization is nothing but optimization techniques. So that is nothing but a prescriptive analysis. Okay, so this is a very, very important part. So for the linear model, that is the prediction model, and we go for regularization, that is the optimization model. So so why it is optimization? Because our main objective is to minimize this RSS. Minimize this RSS, not only is reach in lasso as well as the elastic. So this is the RSS part, minimization. And this is the combined part. So naturally, we have to, this is a combined part with some penalty. Penalty, and I will tell you lambda is the tuning parameter that in example I will tell you. Okay, so lambda is the tuning parameter. So now, why it is optimization problem? Because our objective is to minimize of the RSS with some subjective constant based on some decision variable. So here the decision variable are the beta coefficients. So that is the subjective coefficient is nothing but the penalty. Okay, and and naturally this reach regulation is called the L2 norm. I'm not going in mathematics. Why it is L2 norm? Because reach regulation. Hello. Some noise is coming.
Yes, sir, your voice is clear.
Yes,
Can I start? Okay.
Yes, sir.
So
Yes, sir.
now this is the decision variable beta. This is the subject to the constants. And just you think, if I consider the two predictor variable, 2x1, x2, so for the two predictor variable, we get the two beta coefficient, beta 1, beta 2. So what is your penalty? Now lambda beta 1 square plus beta 2 square. In case of penalty, we will not consider the intercept form, the intercept term, that is beta naught. But in our model, there is some constant or intercept of y. Okay, now this beta 1 square plus beta 2 square, if you consider the equation of a circle, that is the x square plus y square equal to a square, where a square is the radius, and circle passing through the origin. Why we consider the reach these are the subject to the constant we have taken as a circle. That is beta 1 square plus beta 2 square less than equal to say s or lambda. You can put some restriction. Okay, inequality, and obviously beta 1 square beta 2 square can be negative. So obviously it satisfies the non-negativity condition. So we can say it is an optimization problem. Not only that, it is a non-linear optimization problem, because your objective function is a non-linear. Square it is there, and objective and subjective also non-linear. So these reach, lasso, and elastic net all are the non-linear optimization problem. So try to understand, we are solving a linear model with a non-linear optimization problem for the just maintaining the regularization or maintaining the overfitting. Because so already I am told you why overfitting is very dangerous, because we need to say some pattern throughout the data set, and that's why we divide the data set into training and testing, and we feed the model, again repeat, with the training data and validate the model with the testing data. So definitely there are some matching with the training result and testing results. So if we don't get the matching, then we go for regularization. So what type of matching? You're the minimum variance, high bias. Okay, and variance is not less. So these are the matching. We have to match with the training and testing data. Okay, so now this is the reason for that. Now we go for some example. Then you can easily understand. So I have started with a very, very simple example for your understanding. Then when you when we can apply, for which type of example, the question of overfitting will come. Not only that, for which type of question we can apply this regression technique. So I have taken a simple example that anyone can understand. The regression is one of the simplest and most commonly used statistical modeling technique. Will help to understand how the response variable, that is the current salary, is affected by the other predictor variables. Suppose we considering current salary which I am getting now, so that is depending on some predictor variable which are called educational level, job category, beginning salary, and previous age. We have taken only 4 variables, okay, and definitely you have some data set. Okay, so now one of the underlying assumption of regression is that there is no dependence on multicollinearity. This is the assumption of regression. But when this assumption failed, so then the question of overfitting or the regression technique will come. So between the predictor variables, but in the era of big data, it is quite difficult to find data without such dependencies, the presence of which gives us the misleading results. Okay. So with this analysis, we wanted to take a look at the regression techniques which might help us to obtain more accurate models and stable coefficient estimates. So this is our objective of my study. So this is my data set, includes the 474 employees with the 5 characters. 5 characters means 5 variables. One is the educational level, job category. These are the 4 independent or predicting variable, and one is the dependent variable, that is the current salary. Okay, and 474 is the number of observations. Now, how to do that? Parameter is, this is a, the residual sum of square. Already I told you. So this is our the model, predicted model, and yi minus the the ith value of the predicted. Okay, so this is the residual sum of square that that part. And so our objective is to minimize this residual sum of square. So when it is minimized, when y and fxi are more or less equal, so then the RSS will be minimized. So this is a simple mathematics. Now coming to this next part, multicollinearity and detection. This is very, very important part before going to the overfitting problem or regulation. Multicollinearity occurs when there are high correlation among predictor variables and leading to unreliable and unstable estimates of the regression coefficient. Obviously, if we get the multicollinearity, so naturally there is a cause of unreliable and unstable estimate of the regression coefficient. So it is not always mandatory to fix the multicollinearity. It all depends on the primary goal of the regression model. Already I told you that is basically based on your domain expert. Okay. But in the case we want to understand the significance of the predictor variables with the response variable. That is the response variable means here it is called the there is a current salary response dependent variable. For how certain factors affect a particular disease, which become necessary for multicollinearity. So naturally, in case of classification problem, the huge problem of multicollinearity will come. Okay. So these are the methods of detecting multicollinearity. So naturally, today it's not possible to explain all the methods. If I can solve the VIF. VIF means the variance inflation factors. Another method is the condition index. Basically, it's based on the eigenvalue. That what I'll discuss in the second session. Eigenvalue, and that is the singular value decomposition. This is a very famous, very, very famous. Okay. Now, so then VIFs give a good measures of overall collinearity, but still they are unable to elucidate the structure of the several coexisting near dependency. Hence, an examination of the eigenvectors corresponding to small singular value becomes necessary. So what is the meaning of small singular value? That I will discuss in the second session. So in reality, singular value decomposition can be the most effective in case of the huge value of data. Okay. Now, the why regulation. So there are several practical problems and computational problems in the regression analysis. Okay, and such as the multicollinearity and high dimension. That is a very, very important part. High dimensionality. Our main objective of the multivariate analysis is how to reduce the dimension. Okay, dimension. That's that part I will discuss in the second session. That's the dimension reduction and regulations or penalized regression. That is basically another thing we'll say. Penalized regression is a modern approach to choosing a regression model with high prediction accuracy. That is the main objective. The penalized regression has the advantage of producing more stable results in highly correlated data. Again, I'm telling you, there is a multicollinearity and data that has a much large number of predictors than the sample size. This is very, very large number of predictors. And I'll go for the second session. And there are the three regularization methods already discussed. So this is already this diagram. This is the bias variance diagram. So I'm not going, because question is why this diagram is needed. That part I'm discussing. Okay. Actually, this is the model complexity, and that is the error. So everyone knows when the model complexity grows, bias decreases, bias square decrease. That everyone knows. So that's why but we need a the optimal model complexity. So our objective is to trade off the bias variance. That is our main objective. When we get some model, we get some consistent model where the bias and variance is the low. Okay, and that is also a optimization problem, and that optimization problem is solved by the regularization technique. Now we know that variance is why it will occur, because variance is not entirely unbiased. Okay, and hence we reduce the variance which might occur due to the multivariate or huge number of variables as the cost of introducing some more bias agent. This is a very, very important term. Yeah, what is our objective? Due to the multivariate or huge number of variables, we have to reduce variance. And that reduced variance, we need introducing some more bias in the form of penalty terms into the existing model. So that's why this regularization means the penalty to reduce the variance. Okay. Now, this is the ridge regression model. Now, ridge regression is a technique of regularization which is particularly useful to mitigate the problem of multivariate that you know. And this is the penalty term already I discussed, and that is the L2 norm. Okay, when there are, I'm telling you, when there are two variables, that is, it takes the form of circle. When there are three variables, it takes the form of sphere, and when it is more than three variables, it takes the form of hypersphere. So that is in case of the ridge regression, and that is the overall model. That is the optimizing the RSS residual sum of square and the penalty term, where lambda is the tuning parameter. So that part I discussed. Okay. So this is the base of ridge regression, and now come to the lasso. Lasso is the least absolute shrinkage and selection operator. That is the lasso, and it is first introduced by Tifsirani. Actually, Tifsirani in 1996 he discovered this lasso shrinkage regression coefficient from particular variable with high correlation with errors. Okay, being either zero or near. This is the main objective of lasso. How to predict some predictor variables to become zero. Okay. So this is the lasso penalty function is given the modulus of that. Question is why modulus? Because it is formed satisfy the L1 norm. And what is the L1 norm structure is this takes a dimension for the two variable, and for the three variable it takes a the polyhedron type extension dimension. And when it is more than, naturally in big data, when it is more than three variable, it takes a polytope. So that is that part I'm not discussing. So this is called the the penalty term, and this is your most model parameter now estimated. This is the model. L is the RSS part loss function, and that is the penalty term, and lambda is the tuning parameter. Now we come to the hybrid penalty. That's the elastic net. This is a very, very important, and that is a convex combination. And this is basically reach part, and this is basically the lasso part, and lambda is the tuning parameter that we know. And what is alpha is the mixing parameter. Okay. And now this equal to 1 minus alpha. Obviously, alpha lies between 0 to 1 because it is a convex combination. And if we take alpha equal to 1, so this part will vanish. That is, the reach part will vanish. So that means when you write the program in RStudio or Python, and if you put alpha equal to 1, so naturally machine will understand you want to do the lasso. This is very simple. Programming is very simple. Okay. So naturally, if we put the alpha equal to 0, so automatically alpha equal to 0, we get the the reach part. And if the value of alpha lies between 0 to 1, so then suppose alpha taking the value say 0.04, 0.0, that means the problem is solved by the elastic net. So, and solving this, I'm telling you, solving these three methods. One method is the regression method. From regression method, we get the residual sum of square. You solve by the ridge regression, we get some estimates of the beta. Okay, estimates of beta. Not only that, from the ridge regression, we get some value of residual sum of square. Better to say you can get some value of r square, adjust everything. Okay. And similarly from lasso, again you get the idea of the coefficients. Again from the elastic you get the idea of coefficients. So from the four method, the conventional method and the regularization method, we get the idea of the all coefficients. And after getting this idea, so we can compare for your model, for your data set, which model is preferable. So that is basically based on your domain. And when you today I am showing a simple example that okay. So now these are basically the penalty method. Okay. Now I'm coming to these steps of algorithm. Suppose you want to write the problem in some R or Python. So I am giving the algorithm from RStudio. So everyone knows the R is basically a combination of the library and some library packages and some function. So include this for this solving this regularization technique. You include these library functions. Okay, I'm not going in detail. I'll import the data set. Naturally, you can from data set import the data set. You can from Excel, that is a CSV file, from SPSS and from R also. And visualization of data already I discussed scatter diagram. This is very, very important. Change the assumption of the linear model. All assumptions, there are so many assumptions. Define independent variable and dependent variable from your domain. Perform scatter diagram from the checking the linearity with the dependent variable and independent variable. Now we go for the machine learning. That is a divide the the data set in two parts. One is the training and testing. Okay, and last the regression with the LM function, that is the linear model function. That is basically from training we get some from some results, from testing we get some results. And now check the summary of the regression output, including R square, adjust R square, ANOVA and coefficient table with the p-value. Okay, and this is very, very important part. Check the VI value. VI value. So this is the just a thing. VI also checking with the beta coefficient. And this VI multicollinearity occurs because beta is the decision making parameter. So that's why, and these decision making parameter based on my observation, based on my data set. So we can compute this R square on the basis of my data. Okay, that's why you are calculating VI beta j on the basis of R square xj. What is the meaning? When xj depending on the other variable, there's a minus j. Very interesting notation. Xj means one variable depending on the other variables. That part we are calculating the VIF, and there is a thumb rule that if VIF is more than 2, more than 5, and basically we consider the high multiplicity occurs. Okay, so now this is the R square from a regression of xj onto all the other predictors. If R square x is close to 1, the collinearity here it is wrong. R square is the close to 1. Naturally, it is called the tolerance. R square is close to 1 means the explained part is more. So naturally, automatically the collinearity is present, and so the VI will be large. If we put the R square value 0.5, we get the VI 2. If we get the R square value greater than 0.5, we get VI value greater than 2. If we put R square equal to 0.8, we get VI 5, 0.9, VI 10. So in this way, when R square reaching to 1, so VI value are more and very large. So this is the, and when the VI value are large, so that means so many multicollinearity occurs. Multicollinearity is a very, very big issue for the regularization techniques. Now, step 10, if the VIF is greater than 2 for all predictor will welcome PCA, that part we'll discuss in the second session. And if there is some multicollinearity occur, then to shrinkage the coefficient of the predictor, we apply the ridge regression. So when we apply ridge regression, now if some multicollinearity occurs, and then to shrinkage the coefficient of the predictor variables, we apply ridge regression. And similarly, to discard the multicollinearity variables, we apply the lasso regression. And to shrinkage the parameter, also to discard some parameters, we apply elastic net, which is the convex combination of region lasso. So this is the mainly, the algorithm of this. So before that, I'm showing how we solve this problem using some open source software like say Jamovie. Okay. So we can open, say, employee data. Already I told you I have taken employee data. This is the employee data. Okay. And in the employee data, we consider just to check, we consider current salary is a dependent, and these are the independent parameters. Already I told you. And we check that here all p-values are less than 0.05. That means all independent variables are significant for determining the current salary. Okay. And not only that, your R square is not so bad, 0.832. So 83.2% explain. Okay. So what we have done in regulation technique, so we, through the R Studio program, because this part, regulation technique can never be solved by this open source software like Jamovi. Okay. So for that, we have to take the help of R Studio directly, or Python you can solve. Okay. And naturally here R square is 0.832 explain, not bad. And when you run this, so if you, there are so many assumptions checking, that is very, very important. For any kind of linear model, there are some assumptions. Okay. What are the assumptions? There is some normality, that part I am not showing because the time is a constant. Okay, we go for the collinearity statistics, which is very important. Collinearity statistics, I am telling you this part will come. And if you check the collinearity statistics, just to check for the education variable, VIF is less than 2. For the job cat, VI is more than 2, self-begin is more than 2. So that means some multiplicity occurs. So definitely we have to think about it. Maybe we have to think, we have to reduce this multiplicity by applying, this regulation technique. Okay. So at least I got some idea. So then what I'll do that, we go for, okay. So now I'm showing, okay. So then, okay. And model fit, and these are the model coefficient. I'm telling you, there are so many tests showing for this linear model. That part, and not only that, this is very, very important part. That is how we check the normality. So there are checking of normality. There are some parametric tests and non-parametric tests. And my today's session basically based on the parametric. So I'm not show the any kind of non-parametric test. So that is a Sapir-Wey's and basically based for the normality test. Okay, but there is some restriction in that the sample size is very less. So then the sample it will not give the good result. Sorry, sample size is very big, it will not give the good result. So then better for your data science, you go for the QQ plot of basic. This is very, very important. Okay, so that is very important. QQ plot of. I'm not going in detail this part. So now after this. So I'm showing a simple part how we can minimize before regulation. Before coming to regulation, how can we minimize this, the concept of overfitting. So for this, you have to take the help of. I have 10 minutes left most probably, so I hope I can complete. So so then I have to take the help of some cross validation technique. So I will show you one or two cross validation because the time is a constant. So just to think what is the cross validation technique. Say what is the cross validation technique? That is very, very important. Okay. Suppose my say n equal to, I am giving a bootstrapping technique first. Okay, what is the meaning of bootstrapping? Very interesting. And then from bootstrapping, you get the idea of bias and unbiasedness. Suppose we take for understanding two samples. So what is the two samples? 1, 2. So these are the two samples. So what is bootstrapping? That is basically based on simple random sampling with replacement. So we can consider 1, 1. We can consider 1, 2. We consider 2, 1. We consider 2, 2. So naturally, total sample space 2 square, that is equal to 4. Okay. And if we take the mean 1, if we take the mean 1.5, and if we take the mean 1.5, and if we take the mean 2, just considering average. And if we take the combined mean, so overall mean, that is 1 plus 1.5 plus 1.5, that is 6 by 4, and that is equal to 1.5. So just a thing, So that means we can show expectation of X bar equal to mu, that's the population. So that is the complete bootstrapping. But in our data science, it's not possible to go for complete bootstrapping, because in our data set, suppose if there are 10 samples, if I start with the 10 samples, the total number of sample space is 10 to the power 10 in the SRSWR method. So we have to reduce this, and that's why we get the biased results. Because to make it unbiased, so that is a very difficult to get the unbiased results. Okay. And that's why bootstrapping gives the unbiased biasness result. So how we remove this biasness result? So I am giving the two types of validation techniques. So that will reduce the bias variance trade-off. So one validation technique is the K-fold. Very interesting technique, K-fold validation. So K-fold cross validation, basically we are considering for data science K5 basal K10. Okay. K-fold. So what is the meaning of K5? Suppose my sample size is 100, so we divide into 5-fold. Okay, and each fold taking 20 observation, say. So this is the fold 1, fold 2, fold 3, fold 4, fold 5. So we consider fold 1, fold 2, fold 3, fold 4, 1 is a training data, and we test with the fold 5. Similarly, we consider fold 2, fold 3, fold 4, fold 5 as a training data, and we test with the fold 2. So in this way, we get the different type of error, and we take the average. You can take the average to minimize this overfitting. So this is one way concept. Another concept is the LOCP. Okay. So this is one way, one out cross validation. So suppose we have 10 observation. So one observation deleted, and we train the observation on n-1 observation, and we test it one observation. And similarly, we replace someone. So all time n- observation, 1- observation is fixed. So we get there are n MAC, n error of test error, and we take the average of that. So that is very simple thing. So now I'm going in detail. And last part I'm showing because today I know I have no time at all. So that's why I'm showing this total part I have given in the RStudio programming, and that is given in the note part, including all types of regularization, lasso, regression, and elastic net. So naturally, if we show by RStudio, so we have to illustrate every line. So naturally, I have no time. So I will tell you in the second session, I will show you one art part, RStudio language part, because that program part is very less. So that is the feature selection and engineering part. Okay. So, but now it is not possible to. So that's why I have given in the notepad. So I hope cross validation. So I'm giving us just summary of my total class in 2 minutes. So I start with the parameter and statistics, and then we go for the different types of univariate, bivariate, and multivariate. And and then I show I've shown you the concept of the linear model, and why we transform from univariate to bivariate to multivariate. Okay, that part, because and then I will show what is the concept of the simple model to complex model. Okay, and why? Because simplest model is the underfitting, and naturally we go for the overfitting model, and we regularization. Basically, we apply regularization for the overfitting model, and then I have shown you what is the meaning of the physically, what is the meaning of bias. Okay, and how the high bias will affect your physical domain knowledge. Very crucially. So then what I will do, our main objective is how to the trade-off of bias variance. And before bias variance, we can get the take of the different cross validation technique, including the bootstrapping, and so on. But the bootstrapping problem is if the number of samples are very high, large, so definitely so many bootstrapping techniques, so we will not get the unbiased data. And so that's why bias will come. And how to minimize this bias? So we apply some cross validation technique, like the fold cross validation, or the Lucy or one-way cross validation technique. Okay, one-out cross validation technique. And in this way, then we go for the regularization technique, and ultimately we take some example. And on the basis of example, we try to understand what is the multi-cognitive. Everything multiplicity occurs, what is the formula, already I have shown it, and then I have tried to give some RStudio program, use it for giving the concept of ridge lasso and elastic net for the training as well as the testing data. So I like to, most probably now my time is finished, it is now 11:30. So thank you for your real patience, if you allow me. So if you have any question, I'll try to answer your question.
Yes, sir. Hi, sir. My name is Saril, sir. What are degrees of freedom and how are they interpreted?
Hello? Hello, tell me. Hello. Hello, can you repeat your question?
So, what are degrees of freedom and how are they interpreted?
Okay.
Evaluated.
I am telling you degrees of freedom. I am telling you this is a very important question you have asked me, because in the degrees of freedom part, due to the time constraint I am now discussing, and that part I discuss in the second session. Because if you why degrees of freedom is important, if I'm telling you, if your number of sample observation is less than number of predicted variable, so definitely the degrees of freedom will be coming negative in your full model. Okay, because for when you compute the adjusted R square, that is, you have to divide by the degrees of freedom. Okay, so adjusted R square means RSS means RSS divided by n minus k minus 1, where n is the number of observation, k is the number of predicting variable, and and definitely this question is valid if n is less than k. So obviously the degrees of freedom will be negative. And that's why in the next session I will show you so different selection technique, because in the data science we will face a problem for the sum data maybe n less than b. Then how we tackle this problem? That part I will discuss in the next part. And for the next part I will discuss in detail about the degrees of freedom. It's a very good question.
Sure, sir. One more question, sir.
Okay.
While you are using the Jamovi software, sir, even I also use it. So I had a question about the difference.
No, actually I'm using Jamovi software. I'm using Jamovi software. I'm telling you because it is open source. Number one is the backend is RStudio. Okay, so there are so many software like the StatCat, but these are not the open source. SPS is also not open source, but easily, SPS is easily visible the demo version. You can easily visible demo version, but SPSS is backend is Python. That's why I have shown SPSS and Jamovi both. And RStudio, that that is open source, powerful software. And maximum machine learning programming are solved by the Python. Maximum. So I know in some session there will be some Python session. So that's why I'm not sure. Okay, that is my objective.
Goutam sir, if it is possible, you can stop presenting so you can actually view who is asking the question, sir.
Okay. Sorry.
Can I ask the question?
Okay. Now.
Sure.
So my question was the difference among general linear model, generalized linear model, and linear regression model.
Generalized linear model and general model and linear model. I'm telling you, suppose I have some p predicting variable, okay, and in the basis of p predicting variable, we can consider one predicting model, that is, we can fit a model with the one predictor, that is a linear model. We can fit a model with a two predictor model. Okay, that is the combination of x1, x2, and so on. And similarly, we can some model we can get x1 into x2 square. Okay, so there are so many combination will come. So that is called the generalized linear model. So that is the mixture of all. So that part naturally I have no time to cover this. That is a very interesting part. And obviously, when you go for these, and another thing is the generalized linear model. Generalized linear model consisting of all where the coefficient is the linear. I'm telling you. You can take the x1 square, x2 square, anything, but you have to consider coefficient, that the beta coefficient must be the linear, because we are considering only the linear model, generalized linear model. But when you go for the generalized linear model, so we'll face a problem. That part I will solve in the second part. Definitely, this is the very important question for my second session.
Thank you, sir.
Sir, I think general linear model assumes the distribution of the model as a
That is.
No, I mean actually PC that what I am not discuss now. Okay.
Yeah, it assumes
because
normal
general model like total discussion part.
Allow other distribution too.
No, actually distribution. No. You have to distribute as a distribution. You have to consider is case of parametric model, because when you consider there is some error, so definitely there are some distribution. So
That's why
definitely consider.
I have the same position actually.
Definitely,
What I was
case of linear
general
model
model
also
follow
we have
normal
to
distribution and
linear
generalized
model
allow other
linear model. No. Other distribution. In linear model, we also have to consider the normal model distribution. But other model, other distribution, I'm not discussing because there are so many distribution you have to consider. Because when you get some data set, and then we have to discuss it is a parametric or not. But we are telling parametric means not only normal, it follows so many types of distribution. So there is some multivariate Wissard distribution, say central chi-square distribution, the beta distribution, exponential distribution. So that part for this today's class I'm not covering. Sorry to say.
Okay, sir. Thank you. Next up
That is another aspect of discussion. Another aspect.
Do we have any more questions for sir?
Questions?
Sir, it is fine. So the next session will start at 11:45. So we can, I guess, take one or two questions more, sir. Sir, and if possible, if there is no problem in your bandwidth, you can switch on your camera for the next 5 or 10 minutes, like if it is possible, sir. So that even the students and participants can see.
Okay. Now my camera is on. Oh, sorry.
Sure, sir. Do we have any more questions for sir?
Hello.
Okay, sir. I think everyone has understood what you have taught in this lecture session.
Thank you.
Sir, since we have some minutes left, that point I told you about like 1.5 hours back. Sir, if you could enlighten us with some of the research topics one could cover in this.
There are so many research topics. Already somebody told me the research topic. Actually, research topic basically based on the domain. Okay. Say some from computer science, some from marketing, some from finance, and all are doing their research. So maximum some we are research on the basis of conventional statistics. Okay, and maximum now research basically based on training and testing data. That means in most of our research we are applying the machine learning concept. Okay, maximum research because to get the accuracy of the model. Okay, and not only that, why we give the already one thing I have not mentioned in my lecture, that for when you get some underfitting model, what is the reason for that? Because we are trying to go for the fit with the linear model, but there is some true population is the perfectly the non-linear. So that is the real problem. So that to capture this non-linear part and those so many parts, naturally you get the idea in the 3 days or 3.5 days with so many machine learning concept, deep learning concept will be covered. So that is basically the non-linear part. And maximum machine learning research, I'm telling you, based on the non-linear part. The question is why our real data or data science are not give the true picture of the population as a linear model. That is the real problem. So when you start with the research, it's my not advice, it's my request to all of you. You go for direct data filtering first. Because data basically is divided into the 3 parts. Basically, you can some content in some collect some categorical data, you can collect some scaling data, and categorical data basically based on 2 parts. One is the ordered part and unordered part. So that part is very important. What type of data set you are collecting, and after that, if the data set all are relevant, so that part I'll discuss in the second session. So that is the data filtering part is very important. And if there is outlier, if the influencing part, if leverage. So before going to any analysis, before machine learning, so go fast, you go clean your data. So this is my one advice before going in any research on the basis of your data sets.
Yes, we'll get to hear more from you.
Points here. Somadev, I like to add some points here. There might be some confusion among the participants because this particular faculty development program on data science is for introductory level. Okay, this is not advanced level, so that's why it is not possible to include the research topics as said by Goutam sir. That is different application domain are there. Somebody may be interested.
If I can show some application in machine learning, I have some paper. I have some research paper using machine learning technique. Because if I start, that is not possible to show. Because it is not this is the introductory lecture I'm giving. Because when I represent the research paper, then we have to assume that we know the prerequisite for everything.
Yes, sir. And we have a
This
time
is my
crunch
problem.
also here.
I have no problem to show any research paper, because if I start the research paper, maybe someone will take the interest, but other will not take the interest, because someone
Yes, sir,
may be interested in the basic part. That is my concept. Okay.
Sure, sir. So thank you. We will get to hear more from you when you will be lecturing us on feature selection and extraction today after our lunch session. So thanks a lot. Sir, you actually demonstrated a lot using hands-on using SPSS software and ANOVA software. Many of the participants were asking how to actually implement the machine learning models. We are learning. Yes.
Already I told you before machine learning, so I have to show what is the conventional thing. After this you go, I have solved this thing using RStudio. Because regularization technique can never be solved by SPSS Jamovi. Already I told you. Okay, so that's why I have taken the help of RStudio. And in the next session, I show you using RStudio. Because that part, feature selection and engineering, what I could not solve by the SPSS and Jamovi. But only for the understanding bias, that's why I have taken the help of this. Okay.
Thank you, sir. Yeah.
So thank you to all participants.
Yes, sir.
Thank you, sir.
You check whether Ariful sir have joined or not.
Yes, sir. I cannot.
Okay. So can I? So can I leave now?
Yeah, sure.
Can I leave for 5 to 10 minutes?
Yeah, sure.
Okay.
Has Ariful sir joined?
This conference will now be recorded.
Okay, I think it's recorded, so I shall start. So this is Azure Machine Learning Studio, which is a product by Microsoft. This was initially released in 2015. Luckily, one of many that I got to introduce this tool through Tata Consultancy Services. We had a great partnership with them. So in the initial stage, we started evaluating this tool and given a lot of feedback to Microsoft to incorporate through TCS. And after that, this tool became very popular in the industry, especially all the companies, they're using Microsoft as their primary platform. They're using it, and I have implemented many solutions for some of our clients on this platform end to end. And later on, they also launch Azure Machine Learning services and different other services to scale. So there is another service called Azure Machine Learning on Azure Cloud Platform, which is little different than this, but more or less the underlying framework would be similar. Okay. So this is the link, https studio.azureml.net. So this is the platform, and it is free. So while taking this lecture, if you can maybe log on to this, sign up with your personal email ID, you will get Can you go on mute, please, if you're not speaking? Anybody on the call?
Dheeraj sir, please mute your account since it is creating an issue.
Okay, thank you. So, so this is the platform where we, in a while, we'll go there and see what all we can do there. But uh, so this is the primary link, one link where you can get everything, all the documentation and all of this. So you can try on your mobile or anything that you are using right now. You can type in and see what is this platform all about. But don't worry if you don't want to do it. So quickly we'll go through like what are the underlying architecture, right? So this is called in short ML Studio. In ML Studio, we can perform all the machine learning modeling and you can implement them into production. So typically we process the data, we uh, analyze and perform the variable reduction, right? I'm sure you already got familiarity with these terminologies, but I'll take you through when I actually build some model. And extract features means the important variables, and you can train and score some data, right? All type of machine learning, right? Supervised, unsupervised type of machine learning you can do. Also, you can do text analytics. You can do some other thing, and you can connect various data sources. So some of the modern data sources like Hive, Azure, some of the data you can connect, and also some open data, a lot of government data you can connect, and CSV data, comma separated value, TSV, like tab separated value, that all you can do. And then you can write back the scored data in a particular location, right, on the Azure cloud, or you can export to Excel CSV, or you can integrate with various other tools or languages that you would like to use, right? So this is a simple architecture. So on the left side, you have create experiments, which is like you create your machine learning experiment, because you do experiment. Basically, machine learning, we do experiment and learn, right? And then we tell machine that this is the best model. Otherwise, machine will run only the default model. So we'll do experiment, and that's why it's called experiments. Uh, so this one is basically overall capabilities of that platform, and exactly some of the things that we would do. On the left hand side, let me take the pointer. So here, if you see the machine learning techniques, there are a lot. I'm sure you did not get a chance to learn all of this, but typically we perform few kind of analysis. One of them is like classification, which is the most common application of machine learning, classifying certain things, right? Good, bad, respondent, non-respondent, fraud, not fraud, right? Or maybe letters or images. So most of the things we do is classification, which is very common. Then the next one is the regression, which is like predicting any continuous data or quantity, right? Sales. So you want to see predict the sales, or you want to predict maybe temperature or something, or maybe yield or any productivity. So that kind of regression modeling we do. And then there are like clustering, where you do grouping certain objects or people or anything with similar properties into certain classes, right? So that type of exercise called clustering. Only few of the techniques available there. K-means clustering is used there, but there are other options using R, Python to do more other type of clustering. Then few special cases where you do anomaly detections, right? like in cybersecurity, like any a threat you want to detect, you can do that. Anti-money laundering on all of these, or you can use that, or there are rare event kind of thing that you can do. Certain things occurring uh, in once in a while, right? So then in that case, you can use that kind of anomaly detection modeling. So there are various other techniques, certain statistical functions you can use, right, to understand uh, the pattern of the data, descriptive statistics. You want to perform certain testing of hypothesis, you can do. You want to know correlation between uh, different variables that you can do. And also you can do text analytics, right? Basic text analytics to extract feature from text, or named entity recognition, or some text to hash conversion, or numeric conversion. And then you can do the computer vision using OpenCV library. Computer vision is like some of the image processing that you can do. In the middle, if you see, this is would be the typical architecture of the any experiment, and it's visually you can inspect that at what stage what is happening, and it is just drag and drop. There are many tools available like these, like Rapid Miner, Alteryx, K9, Data IQ, Data Robot. There are various tools, and I think more and more will come in the future, right? This is very easy to use tool, and this would be the typical architecture. You import the data, or you connect the data, you process whatever processing required, then we do the splitting, train and test, and then we train model. This left hand side, all the model you can just bring in built-in machine learning algorithm, and then you train them, and then you score on the new data, right? And then after that, you can put that into production through web services or API. You can do, and you can see each of the stage what kind of data that we can import or connect. We can process some of the things like cleaning missing data, renaming the variable name or column name. You want to filter, you want to do some advanced analysis, or you want to transform the data using SQL, Python, or all of this that you can do. Okay. So I'll skip this, but this one is basically in what scenario, what kind of model that you are going to select. It would be very useful to look at. So I have already explained like the text analytics, regression, and classification problems, and there are options available. So this is the link where aka.ms/ml cheat sheet, which you can go and have a look at it, right? And see that for what kind of problem you can use what kind of technique, right? There are multiple techniques can be used to solve one problem and get the best model or ensemble model, that kind of things that you can do. So in machine learning, you have to be open to do experiment, mix and matches. There is no perfect model, or there is no one model for um, any particular problem. So based on your use case, based on your data, based on your uh, your requirement, there are a lot of business use cases that you bring in, business logic that you bring in here, which would be very important for you to look at, right? So, and then if you see here, some of the reference document, though you do not need them, when we go to the platform, we'll see from, you can navigate from there everywhere, right? But I have added few links here, which is basically the documentation of the studio. If you want to ask any question, people will answer there, and then there are a lot of community examples where you can develop and contribute. And this is one of the important repository where a lot of data available, right? And of course Google, where you can search everything. So whenever any doubt, you go to Google and search, and that's the best way to learn and see what others are doing in worldwide, right? So now I'll go to the platform. So this document would be available, or maybe you need to note down here. If you want to note down some of the things, I'll maybe spend 1 minute. If you want to note down some of the links, or let me copy paste on the chat window. Let me do that quickly. Okay, and this is the link. Sorry. So this is the platform. If anybody want to log in, just quickly register. It will take maybe 1-2 minutes to do it. Let's go to the platform, and then we can learn something cool. Okay, so if you see here on the first page, you will see some of the updates on the left hand side, whatever new thing added to the platform, what are the changes that Microsoft is doing, what other things, so they'll be posting here. So this is about the studio, all the details. You can read more if you go to the home page, and all of these are very, very useful, right? If you see how to use, see, this is the ML infographics which I was just showing, right? So you can look at that, all available here. Some of the hands-on lab, there are a lot of information and the resources free. A lot of examples would be there, right? So go through it whenever you get time, or if you have further interest. So this is the home page. When you sign in, so if you sign in, then it will take you to the platform. And this would be the platform where you'll be working on. When you first time log in, it will say, okay, take tour. So if you take a tour, it will show you some of the steps, right? How to navigate through this platform. So it will tell you, right, how to go it. So if you see, first time we create blank experiment, and this is typically architecture which was shown on the presentation, right? You will get something like that. And then a lot of sample data sets available for you, right? On the left side, where you can use the sample data to do your experiment if you do not have data, and you can analyze them, right? Something of this sort you will be looking at. This is a sample experiment, and you can see quickly the distribution of each of the column available within the data, right? And if you want to do some analysis, you can do it like this, right? So let us quickly look at what all options available. So anything you want to start, you have to start from this new, where you can click on new. You can create new experiment. You can create new project. You can create new data set. You can create new module. And you can also start from a lot of examples here, Okay, so from the gallery, so a lot of examples available. So you can use one of them, and then you can see how they are created. All different techniques, clustering. We'll look at some of them, right? Text analytics, time series analysis, all of them available. Neural network. So if you would like to experiment, you can look at or click on them, and then you can modify them. You can recreate them. So that's how you can learn. Any data that you want to upload from your file, you can just click on this and then choose a file, and you can upload from your folder wherever the data is, right? You can do that, CSV or TSV data. We'll see other options. And then on the left hand side, you can create your own project folder you to organize, right? You can see as your ML training, you can create another folder where you can organize certain projects into one folder. So it is more of a housekeeping. This is called web services, where you can actually deploy directly your machine learning model as API and web services. So this is one of the cool feature where you don't have to write any code, but you can just directly create API. And this is the data set, where any data set that you upload or save, it will be saved here, your own data. And then any models after training you want to save here, you can save the models for future reference, right? You can save the model here, and then you can reuse. You can actually call this model in different experiment. And you have some settings. So typically, if you see in settings, you have a workspace name. This is a free workspace. You have a workspace ID. If you want to interact with this workspace with other languages for the programmers, you can do that. And you have 10 gigabytes of free space available to do the experiment. On more than that, you need to buy a paid version from Microsoft. And then if you want to know more about workspace, you can click here. Then for this workspace, you have an authorization key. When you connect from outside, you need authorization key. You can regenerate, and you can invite some users here. Like I've invited one of my friend to look at what I'm doing. You can just invite user and just type their email. You can assign either owner or users. They can come and look at this. So this is how you can share your workspace so that they can come and work on your experiment or collaborate together. And this is some data gateways. So you can create some data gateway to connect your database servers or something where you need to bring in data from data warehouse or data lake or any data. So you need to create data gateways, or from on-premise system, you can create data gateway. And then that data, it's not available with the free tier, of course, but in a standard tier, it is available. So certain features you will not get here. And then here you can have multiple workspaces, like you are working for multiple geographies or maybe business. So you can see there are different geographies available. So you can have multiple workspaces based on your subscription or administration, right? So you can have multiple subscription. I don't have any subscription in other areas, so it's only free one available, and you can see, you can navigate between your workspaces. And any help, you can definitely some ask question, go to documentation, you can navigate from here. And yeah, of course you send smiley to Microsoft, right? So this is typically the environment. And bottom of this, you can of course refresh. Yeah, API is application programming interface. Sorry, I had to explain that. Yeah, and then these are primary thing, like the experiment which we are talking about, right? The experiment where we'll cook everything, right? And we'll do the experiment. And other services of Microsoft available here, Cortana, Intelligence, Gallery, and all of this, but primarily we'll be using Azure Machine Learning. So this is the one we'll be using, the Studio. So this is the platform. And let's go to the experiment. And you see that whatever experiment you will create, it will be saved here. You can rename them on any sample experiment that you want to bring in. You can keep it there. I'll just want to show, right, some sample data sets are saved. Now let's create new experiment. So as I mentioned, like you can create experiment from here, new experiment. I'll show you how it will typically look like, and then we'll create one. Okay. So this is a sample experiment I've just created for this purpose, but I'll recreate here. Let me make it a little bit tiny. So you can import data from any location. So the UCI machine learning portal that I have shared. So there are lots of data available. So let's go to UCI machine learning and see what is there. UCI machine learning, if you do not recall, just type here, and the first one will come, the machine learning repository. And there are close to 600 data sets available, right, for different experiments. These are all real life data, all different industries, and you can search and you can use, and in your research paper or study you can cite them, right? And very useful. Even the iris data that we used to use, so that is also available here. So all the data would be there. So very commonly used data like wine quality, iris data, then default prediction in bank, right? Predictive maintenance, a lot of data available here. So all different use cases. So I'll use one of the data which is right of identifying bank note, whether the bank note is a correct one or not, right? So let me see where is the data. So if you can search this, let's see if we get any data here. So another good description is a small data. There are lots of bigger data available. So there are 4 features. Am I audible?
Yes, sir.
Yeah, so I think someone not able to hear me, probably a request to rejoin. So if someone can type to rejoin, thank you. So these are kind of features available. These are some transform data. Of course, in real life, you will not get that clean data. You have to do a lot of pre-processing and clean them, and then you can definitely get the right result. But a lot of data are cleaned, and based on that, a lot of papers being developed, and description is available. So I'll just type this also on chat, so that if you want to do the experiment with the same data, you can get it. Okay, and so this is a text format, but a lot of data, zip data and different other format. So I've downloaded the data, and there are other data also available here in the parent directory, and some explanation available. Let us look at quickly what is that data all about. So what I'm doing is, all the, let's create a new one on Azure Machine Learning. So there's a lot of resources available. So let's create a new experiment. It's called new. When you say new experiment, it will come as a blank experiment. And on the top, it will be like this experiment created on this, but we just change it. You say that bank note classification. Classification experiment, or whatever you want to call it as per your convenience. So you can start like this. And then first thing is required to get the data. Either I can upload the data from here. We can just go to data set and upload. Something like that we can do. We can upload from here and you can name it as your training data and etc. But given that the data is online available, we can directly connect the data. So if you see in the self-explanatory on your left side, right? So data input, output. So when you want to import data, we'll go to data input and output. So IO. So there are options available. You can enter data manually. A lot of cases we use quickly sample data. Nowadays we don't definitely do manually. We can export data to save in other location. We can do import data and then unpack zip data sets. A lot of data in zip format you can to unpack. So let's go here. We just drag and drop import data. So you can see the first one. And on the right side is giving options. What is your data source? So you can see there are different options available. What are different data sources that you can connect? This is one from web. So the link that we have, we'll just I'll go here again. So go to the data folder. We'll just copy the link. And then we come back. And then I paste. Okay. And we do not know whether this data has a header or not. So first time we can do, okay, leave that as it is. So this data is basically CSV data. So you can select what are the format. So it's CSV data. And there's a caching option, right? If you want to call once and use it in the future, it's a large data set, you do not want to run the link again and again, you can click on this so that it will not run. And it will be saved. It is run once, right? A one-time execution, and then it will be saved in for future experiment. But let us quickly run this. Once you that, you can right click on that and run selected, or you can just do from bottom of this, you select this one and then you can say run selected or just run. So if we run it, then basically it will be calling that link and try to establish connection. So once that is done, you can check the data format, like visualize, right click and just visualize. Excuse me. So you see this data, there is no column header, but a lot of data you will have the header name. So it is like column 1, column 2, column 3, column 4, column 5, right? And if you go here in the data dictionary, so it is given the explanation. The first one is variance of wavelet transformed image. Second one is the skewness of wavelet transformed image. These are some statistical terms, descriptive statistics, variance, skewness, kurtosis. A lot of people use C, a lot of people use K, right? Kurtosis, entropy. So if you do not know, if you can go quickly do Google of these terminologies. So if you are working on machine learning, I will suggest that you study basic statistics, descriptive statistics, and testing of hypothesis. That would be very much useful throughout your life. And this is the class integer, which is typically 0, 1, which is your label, whether that particular note is um, proper note or not, right? So this is the column 5, which is your label, and you can on the right side look at the distribution. So if you see, you can see the quick distribution of your thing. So most are 0 and 1. Their distribution you can look at. Of course, it is binary, so no point to look at mean, median, and all of this. So you can see minimum 1, maximum. Minimum 0, maximum 1, and unique values 2. So right, these are 0. So you can see all of this, right? You can see distribution of other continuous variables, how they are distributed. You can look at the density, cumulative distribution. Quickly, you can look at. You can just save your data and all of this, and then you can look at mean, median, mode, standard deviation, all of this. So this is quick view of the data. So this is how you can visualize. You want to compute further statistical metric. You can just bring the summarized data. You can bring that here like drag and drop. You can connect again, and you can just run. Like we any program language or any tool we summarize, you can quickly summarize this like this. Okay. Now we know the data. So you can summarize, and you need to, based on the summarization, if you need to make any decision for transformation, like you want to use lock function or anything that you would like to do, you can use it. Very interestingly, if you click of any of these box on the right side, you will see a quick help here. So if you click on this more help, it will take you to the page with all details. This is very useful. And if you see the entire documentation, you can download as PDF, like I think it would be 1700 pages book. So you can download for your reference. But it's better to go with the quick reference, and they will explain what all it is, right? All these percentiles, all of this, right? So that it is easy for you to understand. So this is a quick feature available on the platform. Okay, now that summarizing done, let's see what kind of summarization is done, right? So all the column, their count, unique count, missing count, there is no missing in the data, minimum, maximum, quartile. So in one click, you can do the percentiles, right? Typically, on student marks, you want to calculate percentiles, right? So all this you can do. Skewness, kurtosis, all of this you can look at here. And then you can just copy this data into your Excel or wherever you want to do. And bottom of this, you will have the histogram here. You can compare one data with others, right? That you can do. So you can do a lot of things. You can do quick binning. You can change the scaling just to see how the distribution is changing. So this is a very good feature. Okay. Now that we know that data is clean, of course, we do a lot of transformation. So we'll not do some of the transformation here. It's so you can do filtering. You can do some other manipulation. We'll do one quick manipulation just to look at what is my target variable. So you can do a lot of things. You can do the sampling. You can join multiple data. You can use SQL transformation. You can add more data, add rows, add columns. All of this you can do. So what I will do, I'll quickly take this edit metadata here. You can rearrange them as you wish. I'll do this edit metadata. I want to just change the one of the column name, like the column 5 here, which is, this is the column 5, which is your basically target. So you just select this. This is data type. You can change if you want to change. No need to change, it's already numeric. You can change to like this is integer um, by default. So if you see anything that needs to be changed, you can change here. And then it is categorical. So it is already categorical. So you can want to make categorical, you can make categorical. If not, but I want to change this column is my column name, right? Which is maybe good, bad kind of things, right? Or maybe my target, whatever we can do. So it is my target or label, whatever you can do. So let's do label. So labeling that target variable, and then you just run it. So it will run only the modified one. So if you see here, it is running every time whenever we are running it, because we have not done the caching. When we do the caching, it will not run this part. So what I'll do is, for next time, I'll put as like use cached result so that we can save time, right? So now we have this edited metadata, and let's see if that change. If you see, this last one has changed to label, right? It's so easy. Okay, now let's build a model. There are many options available, so we'll not use all of them today. You can bring in Python a script. If you can write Python script, if you want to write R script, you can write R script. Okay, sure. So if you look at here, this is the import data. So we import data from web location or any other location. So there is a caching option. So caching option is like it will save in memory. One time you run, the next time you don't have to run. As a large scale data you are bringing from the data or sampling it, so it can save time. So you do the caching, so next time it will be using the data already available on this platform. So, and then if you need to refresh that data for future purpose, you can remove the caching. Then as we have seen here, the data, there's a column 1, column 2, column 3, column 4. There is no proper naming given here, right? But you want to rename them, right? For example, column 5, we want to say this is my target or label. How to do it? So you to go to the data transformation. So the data transformation node, you will get all different options. You want to filter, you want to do manipulation. So this is more of a manipulation. All kind of manipulation you can do. You want to do sample and split, we'll use one of them. You want to scale, like standardization on all of these principal component, normalizing of the data, if you would like to perform, you can do that. So scaling and standardization, you can do that. So I want to just modify one of the names. So I have just done the drag and drop, edit metadata. And then you just connect this to node. On the right hand side, if you want to change the data type, you can do it, but I just wanted to change the column 5 to label. So this is my label with 0 and 1. So to predict whether that node is a good node or not. So let's see, this is a label. And then you can run it. Okay, and see that column name has changed. So this is from column 5 to label. So this is the easy. Anybody using the data, you can use this one. This is the link for the data. Otherwise, you will not get the proper result. So you can use this data if you want to. And then it is changed. Now, in any machine learning process, what we do, we first get the data, and then we do some analysis, we do some transformation. This is the edit metadata. Similarly, we can do clean missing data and other stuff. And then next, what we do is we divide the data into multiple groups for training and test of your data. So what we'll do, and then we do a lot of normalization. So due to time constraint, we'll not do a lot of this kind of analysis, but you can try. You can just bring in the normalize it of the data, and then you can scale. So if you want to bring in one of them here, like normalize the data, and then you want to normalize all numeric data, it will be done. Jet score typically use, you want to use min max, logistic, log normal, tan hyperbolic, some of these option you can use, right, to normalize. So I'll just skip this. And then what we'll do is we split the data into training and test. So you just bring in the split data. We'll do some random sampling. So on the right hand side, if you see their option like split rows, and then other using, you can do regular expression, you can use relative expression, but I want to do split the rows, only the data that I want to split, maybe 80-20. So 80% of the data, so 0.8 is 80%. So 80% of the data will be using to develop the model. You could do 70%, 0.7, and we want to randomize the split, right? So it is without replacement, and you can give any random number so that every time you run it, you get the same data. And there is some concept called stratified split. So stratified means you have 0 and 1. They are distributed maybe in the original data. Let us see how much they are distributed, and we want to maintain the same percentage, right? So if we see here, you can see this around maybe 600 odd is like 1, and then around maybe 800 is like um, 0, right? So this kind of distribution you can expect. So what you would like to do is in your uh, sample data also maintain the same split, right? And that's why you can say stratified sampling. You have large number of data, normally you don't need it, but you want to do stratified on this level, so you want to maintain the same percentage. So you can select that, and then you can just run. So you want to know more about this sampling, you can again click here, or you can uh, read a subject called sample survey, where these are sampling techniques. So there are different methods available, stratified, probabilistic. So you can study that, and then let's run it. Now you see there's a 2 nodes here. So on the left hand side you will get the 80% by default, and the right hand side you will get the 20%. So left hand side you will be using as a test data. You can just write a comment also here. If you click here, there would be option to write your own comment, right? Split in training and 80% test 20%, so that you can refer in the future. So you can just write like something like comment here, and the left hand side your data, which is your training data. On the training data we'll build some model. Now we'll not write any program here, but of course again, as I mentioned, you can go ahead and run all the model using R Python. That options available here. So this is the second step where we typically create test and training and test data. You can create more splits, and then our primary focus is machine learning, right? So here is machine learning. So what we'll do, there are 4 nodes available. So one is initialize model. So by name, like we have to initialize some model. So and then we have to train the model, and then we have to score, and then we have to evaluate. So this would be the order. So first we initialize any model, right? We want to initialize any model, like for example, we want to do classification. We know this is a classification model because it is 0 and 1 binary classification, and that is only 2 class. So you can see there are some inbuilt option available. 2 class Bayesian, 2 class boosted. Let me just make it a little bigger. Yeah, so you can see 2 class average perceptron, decision tree, decision jungle, logistic regression, neural network, support vector machine. So a lot of things are commonly used. So decision jungle, decision forest are similar to random forest. So in Microsoft, they call it this, right? It's almost similar. So random forest is one of the popular technique used. And then logistic regression is mostly commonly used, and then support vector machine, right? And neural network use when you have large data, right? So let's start with one of them. So what we'll do is let's do probably um, maybe logistic regression, which is most commonly used. We'll do one other techniques also, right? So we'll just drag and drop here. 2 class logistic regression. This is my model that I'm going to train. How to train? So there are options of train. So there are some inbuilt functions, auto ML model available. There are also hyper tuning of the parameters that you can do, but this is the train model. You need this. And then what I'll do, I'll connect the training data, the left hand side 80% of the data, and then I connect the model. So this is the model, and then I'll just select here that what is my level. So my level is a target 0 and 1. I'll just select and say okay, and then I'll run. So this is model training will happen like this. It will be very quick. You see, this is using some cloud computation power. So when you use the paid version, that'll be much quicker. You can use that, right? So after that, what we'll do is when training is done, then we score on the test data. So we do the score of the model. What we'll do is we'll do like this, and then the test data on the right side, we'll just connect this. And what we'll do, and then we'll see evaluate. So evaluate model, you can do cross validation. That option also available. Cross validation is like multiple, you split your data in multiple groups, and you can do cross validation. You can do, and then we'll evaluate model, and then we say run. And your model is ready. So I'm running most of the default stuff, and then you can change this model L1, L2, all of this, right? You can put random number, you can use like more other options. So you can parameter range to select the best model. So all this can be done, right? And then we'll right click and then we say visualize. And if you see, it is almost a near perfect model. So 95% accuracy. Now, it could be overfit model also. That's why the hyperparameter tuning is required, right? And it will also create a score bin and see the distribution of your data. And these are some accuracy measures you can look at. Now, based on that, you can decide, okay, what is your cutoff? You say, okay, anything above 73%, you want to call them as a correct node, and or other way around, right? Negative is like 0 and positive is 1. So that's how you can decide your cutoff also and see what the distribution, if other different parameters. I'm not going into deep of this terminologies. So you will learn in different courses, right? True positive, false negative, accuracies. These are different terminologies used for different use cases. Different things look at precision model that you look at like this. Then false positive, false negative. So there would be trade-off that you need to look at. And this is a very good table. You can just copy paste and do more experiment to decide on that, right? So this is like you see the logistic model working very well here. Now I want to run another model and I don't have much time, right? So what I'll do, I'll just select this like this, 4 boxes selected, Control C, and I do just Control V. And then I'm coming here and I want to, instead of, see that's quick, I'm creating another model in a like minute. So instead of logistic regression, I'll run some other model. So let's connect this and connect this experiment. And then let's run some other model. You want to run maybe neural network, 2-class neural network, right? And then same, you want to do score model. You can also compare 2 models like this. You can evaluate here, or you can independently evaluate. So let's run it. So you can see that once you build one framework, the next model, it will take like few seconds to run, right? A few seconds to create, and its running time of course depends on how much data, training data you would have and computation power, right? So while it is running, you can also like right click and save your model like this, right? This is my neural network model. This is my logistic regression model. So you can write like comment and save this model in your save model here so that you can use in the future, right? And create a predictive experiment. Okay, so now let's see, this is like 2 models you can compare in one platform, or you can just evaluate a neural network model here, just that we have seen that model. And it is see lot of cases that neural network you should not be using for small data. This is the reason. It's actually 100% accurate model. And as I mentioned, the data is already there, and you can of course do the hyperparameter tuning. Hyperparameter is like some of the parameters that you can tune here, like for example this number of hidden nodes, learning rate, all of this that you can change, and then you can improve. Okay, so this is like how you can create a bank note classification model very quickly. I'm just checking the time, so how much time I would have. I'll publish this also experiment and share so that anybody would like to look at in the future, you can look at. I'll share reference. So I have 13 minutes and then 15 minutes Q&A, right? Or I have only 13 minutes.
Sir, we have this session till 1:15. So
Okay.
you can, and if any interested
28 minutes.
participants choose to stay on, so we can continue.
Okay, sure. So 28 minutes. Okay, so that's why I say then I'll take it further how to deploy. Maybe I did not plan that, but I'll just quickly take you through how to, once this model is implemented, how we can then deploy into real life use cases, right? How to create the API, so web services and all of this. So for example, this is my best model. Neural network seems to be near like perfect model, and I tend to avoid that because it could be overfit. But I say, okay, logistic regression model is my best model. Let's do one thing. Let's create a pipeline so that I can predict my new node and see how that can be classified, right? So this is how you could do. So you can save the training model. I'll show quickly that I want to save this training model. This is if it is a new version of the existing model, you can just click and you can choose that model and override. But if it is a new model, you can give a name that it is my banknote classification logistic model, logit, for example. And you can provide the description, banknote classification model created at FDP, something like that. You can just put and you can just save, so that you can save your model, and this model will be saved in your training model, right? And you can create new experiment and do that. But from this experiment, quickly we can create a new web service. So what we'll do is we can just say click this one, and then bottom of this you can see there are a lot of things. You can save your experiment like this. You can just save it so that you don't lose anything. You can save with a different name. For example, okay, Poonam said not
Sir, you
audible.
are audible, sir. You are audible.
Okay,
I
thank you.
guess it's a problem from our side.
No problem. Thank you for confirming. So what we can do is, very interestingly, for example, now this is a banknote classification experiment, but the same thing, you want to do the same steps, and in between you can add, remove steps. Okay. So what you want to do is you can use this experiment to do other experiment. For example, you want to do default prediction. So you want to just copy, save as banknote classification experiment. We say, okay, something, anything, right? Default prediction, default classification experiment. You can just save and create a copy of this, and then you can reuse, right? So now you change the data here for the default use cases, and then you can edit, modify all of this, and see this is the framework created. And if you go here, you see these are, you now have two experiments. I created this, and this one is I have just copy, and I want to do something else on that, I can do quickly, right? And so this is the banknote classification experiment that we are working on. So it is super easy that you want to just reuse your experiment and create something new, right? So this is the training model, and then what I can do is I can let's run it, and then I will set up a web service from here. So to set up web services, the predictive web service is recommended. You need to run the experiment first, and then you have to click on the click on any of the model which you want to do. For example, this logistic regression that you would like to do, and then you just say predictive experiment. You can see that it is auto arranging the pipeline, and it is creating some kind of framework. So we have imported the data. So it required that data architecture. So number of features and all of this. That's why it is reading from here. So edit metadata we use for label. We don't need it here. All right, because when you predict new data, you do not have a label. So you can remove this, and then you can connect this, that you want to score a new data. Just this simple. Right, so this is the data that banknote classification we saved. You see the model has come here, and this is the input web services, where you can just change, okay, bank node data, data that you need to give new data, which the new node, and this is, you can say, okay, node classification, I put bank node class, okay, or predicted, whatever you want to put. And of course, in between, you can add more like other steps, right? You can bring in like the data transformation again. You can just want to filter. You can select column in the data. You don't want to select everything. You can just want to select only few. Something like that you would like to do, you can do. So this is called input node. Any API, you will have one input. Another node, you will have output, right? We'll see how that works. So in the select data, let's see if we can select something. So for example, in the predicted, I don't want to keep this raw data, right? All the raw data, but I want to just keep this code labels and this probability. Okay. And another thing is like in this data, we have given the labels also, but when you actually have a new data, you will not have labels. So what we'll do is, again, we'll put a select column here just to get the architecture. So column 5 you don't need. If you put that, then you have to provide that data. So what we need to do is we need to just select only these 4 features. Okay, and the 5 you don't need. Now this is your web service setup. This is called the predictive experiment. So now what you do, you just run everything. And see, this is created. And once that is created, you can just deploy. See the deploy web services. You just click on this and see this is a banknote classification experiment web services created with an API key, application programming interface, and with a nice documentation. So there are 2 APIs created. One is for request response. If you know what is request response, you send a request one at a time and get back response. And another is batch execution. When you upload entire data in an Excel file or batch, and you see, then you can do some experiment with Excel auto created. And there's a good documentation. If you click here, it will give you how to use this API. So the detailed documentation, so you'll have a API link. So it's a post method. And you see that the JSON input you can send like this, column 1, column 2, column 3, and the JSON output you will get like this. And there are some implementation codes available, C#, Python, and R, how to call this API. So very good, like document you can just save as PDF and use for future purpose. Very automated documentation also created. For this purpose, let us test some of the, you can test quickly here. Like if you have some number like these are random number 1, 0, 5, 10. I'm not sure whether this is the correct data of a note images. You can just want to test and say, okay, this is coming 0 with 21% probability, right? So this is predicted. So this is a new data. Now, while doing that, let me download one of the Excel file here, sample data. And then you can test on the portal. Let's see if the portal opens. Yeah, test is you just click on the test. You just give your now new node, the data, that new node you have, the data for column 1, column 2, column 3, random data that you, I'm typing random data, but you will have the exact data and just type something and just click, and it will return you, say, okay, this is 1 with 50% probability, right? So 0.50. So this is how you can test here your API, whether that API is working or not. But also that API you can directly use in Excel integrated. It is inbuilt, created for a sample. But if you see here, so on the platform, it is kind of front end created where you can upload a CSV file or you can just copy paste CSV. And then you see these are column 1. There is like some of the data. All the features given is a new node, for example, and you just test your API and see what is given. So you given as like a score level is 0 with 3% probability, right? You want to do a batch, you can upload a batch file. For this you need a subscription, right? And you can also look at like all the calls that you have on that this batch, and the API documentation, endpoint documentation will be available here. So this is the platform where all of your API will be monitored and used. Okay, so and this is the API, how to use it. This is also available here. The same thing, the primary key, secondary key of the API. You can create a web template directly on Azure using this in a few clicks. Now that we have downloaded some Excel file, we'll say real life implementation, for example. So this is the last one, and then we can go to question and answer. So this is super quick to implement, right? API, and then you given that API that you can integrate with any your business application. For example, it is Excel here, very rudimentary, but this is a web page where you can see some of these things you can look at. Because we can open up for question while it is opening up. See, this is an Excel application created with the machine learning model that we have developed. And see the banknote classification. If you click here, see this is the input that you can put, and this is kind of schema that you can use. So it will be giving you what kind of schema that you need. This column 1, column 2, column 3. You can rename them, right? In the experiment, you can, for example, this is not column 1, column 2 is very vague, right? So what you want to do is here in your web services experiment, you can rename them. So these web services that we have created, this is saved here. But in the experiment, in predictive experiment, you can click and you can rename this input here. Instead of column 1, column 2, column 3, column 4, you can say, okay, it is skewness, kurtosis, variance, and all of this, right? So you can rename them. So that's how it is. It would be easy for software engineer who are going to implement. And then this is kind of input data. So if you have data, like lot of data here, right? You can score all of them. So for example, let's use some sample data. So let's do some sample data here. So for example, this is column 1, column 2, column 3, column 4, which is like your variance, skewness, kurtosis, and all of this, right? And then you just select this data into your input here. You just say select this range, and then you want to get the output. If you want to include headers, you include headers, and you say that I want to get output from cell E1, right, or some other page, and then you can say sending the response. So there are options like you can say as a first few rows or as a batch. So you can just send to the experiment and see this is they returned you the score and the probability. So it is the 60% probability. This is a bad note or good note, whatever you classify, 0, 1 based on that. And this is a like 0 zeros. So this is how you can get return the score, and based on that you can decide all of these, like in programming language you can write if else then. So okay, if greater than this, then this is my good note, bad note, and all of this in the banking system. Okay, so this is a quick implementation of machine learning model on Azure ML Studio. Now I'm happy to take any question. Of course, you can save this experiment also and then create a new experiment. Like now that we have done the logic regression, in the same experiment, you can bring in another one like neural network and do ensemble. You can do that, or you can save as and then create a new experiment with other experiments. So this is super quick. So log on to this platform and click on all these module, bring on these and say quick help. And then you get all the documentation for your future reference. Thank you. Now I'm happy to take questions.
Do we have any questions for sir? Prabhakar, if you can like just on your audio and then speak the question, that would be better for sir and all of us.
Okay, I am audible.
Yes, sir.
Yes.
Yeah, I wanted to ask whether this can be added in the backend of any application.
That's
Like
what
if
exactly I've shown you in Excel one, right?
yes,
So
yes.
in Excel, you are calling this API, and I have just shown you this API, right? So in the backend, you will be using this API. So this is the backend, right? In backend, you will be using Python, R, or Java, or C Sharp, or something, right? So in the backend,
Okay,
you'll be calling this API with this API key, and you just replace with the API key. Okay.
okay,
So
okay.
this is a sample code given, right? So of course, otherwise there is no point of building this model, right? So so then detailed documentation available on the web services that you have created. Now, given that this model is there, you can call that model from the Python, and then you can build your other API like using Flask or anything if you are a programmer. Okay, but if you're not a programmer, you can just directly use this like Excel kind of application I just demonstrated.
Okay, okay.
Thank you.
Thank you.
Yeah, so that's called ensemble, not hybrid, right? You can of course combine, right? That's what I was trying to show right here. Logistic regression, that one of the model we have used, right? In the experiment here, you can decide based on the, like, there are ensemble method like voting method and all of this that you can use, but most commonly used method ensemble would be like the decision forest or decision jungle that is available, you can use. But these two models, like another model I'll just quickly show you here. This is more flexible, right? For example, I'll save this model also. I don't know what I have done. So this is two models. One is neural network model, and one is logistic regression model. And you need to use both of the model for your experiment, right? So you can save this model also as a neural network model, and then you can use that. And if I go here, so this is another, you can flexibility, you can implement the model directly here. You can score, and then after that you can combine these two and do more manipulation and then write it, or you can just write here code, right? Combine. There are a lot of transformation option available, comparison of the model. So that's why this evaluation is there. So this model and this model you can combine and have the best model while actually implementation. Okay, so ensemble method, for example, here what you will do is, yeah, go ahead others to ask question. I'm just trying to show here. So what you will do is,
So, sir, Sangeeta ma'am actually asks, can we save the model in the local drive and can we import it in some other application? So,
this is a model as Microsoft model. So typically you can save as a model as eyeliner, and then you can do with Python, right? So these models, you see, this is the format, .NET format they use. So typically when you implement it, it actually download this model, not from here, the paid version. Okay. So from the paid version, standard version, you can download this model, and then you can combine with other tools. So this is a trained model, right? And then implement like the predictive experiment created, but it would not be like a Python model and all of this. So there is other version available called Azure Machine Learning. So Azure Machine Learning is a platform where you can deploy that model in Python, Docker, and other all of the thing.
yes,
So
sir.
okay, so you can, on this homepage, if you go, there would be option to compare different machine learning services, and then you can choose which is best suitable for you. Okay, but this model,
Shayali ma'am was
in
asking you a question. Yes, sir.
okay, yeah. Before that, so this in a paid version, you will have a Jupyter notebook here. Okay, so in the Jupyter notebook, you can call Python or R and call this model directly, and then run on Python. Okay, go ahead. Thank you.
Shayali ma'am, please ask your question.
Yes, please.
Strawberry, cherry.
Unable to hear. If you could type.
So Shayali ma'am, if you have any question, you can post it in the comments box. So we'll make sir can read it from there.
Hello.
Yeah.
Hi, sir. This is Salil here. Who's speaking?
Hi, Salil.
Right. So I had a question about the order that you said in the machine learning thing, like initialize, train, score, and evaluate.
Mm-hmm.
So what I understand that what score is. I mean, what is the purpose of score? I mean, implementing the model on the tested test part. But what is the score column mean when you actually visualize?
Score is
I didn't.
probability.
Acha. Okay.
Probability for 0, 1 or A, B, C, D, X, Y, G letter, whatever you want to do. That's called scoring. Probability score. Okay.
Right.
That's
Right.
what you got,
So
no? That's what we got in Excel. Also, if you see here, it's a probability for good and bad, right? So this one, what is the probability of this particular row to be 0, right? It's 6%. And scored level is its predicted level. So you can rename that. It's predicted levels, predicted score, predicted probabilities, nothing else.
right, sir.
Okay.
So your session was really enriching and was full of content, and it was really insightful. So
Thank you.
at this moment, sir, there are not a lot of questions because since you did a hands-on on Azure, and we are actually still awaiting to do it because the moment your session will end, we will just start doing it in Azure, right? So the
Sure.
questions will come up. So is it possible
Send me.
anyway to get connected with you via your mail or
Yeah.
offline like WhatsApp or anything?
Of course. So you can write me, and also you can connect me on LinkedIn. So I'll just type my email ID here.
Sure, sir. Thank you, sir.
You can same email ID. You can connect me on LinkedIn as well as you can. Okay. So let me
And sir,
change.
elaborating on what Salil Bhaiya said, it was really difficult for me to explain, to understand how someone could build an entire machine learning model without writing a single line of code. So you could make it possible, sir, and thank you for showing us that. And it was
Okay.
really a very good session, and thank you, sir.
Thank you. I'm sure it would be helpful to do some experiment and see quick and dirty way to do this model here. But you can just try, okay? Do mistakes and try to fix it, okay?
Yes,
Use
sir.
some of the stuff.
Regarding Microsoft Azure, I would like to ask from the behalf of all the participants as well as me, sir, that since you are using the paid version, sir,
No, this is
maybe
a free
that.
version. This is a free version. You see,
Okay, okay. So, what are the benefits of paid version exactly?
paid version you will have a Jupyter notebook tagged here also. Okay.
Okay.
Also you do parallel computation. This is a only single cluster. So when you have large data, the model will run in multiple cluster at the same time. So it would be faster. So what I'll do
So, we
is
can
like,
train multiple machine learning models at the same time using Azure, sir.
yes. So like
Oh,
I was
that's a
running one
great
logistic,
advantage.
one neural network, one after another. But when you actually run in paid version, both the model will run at the same time, right? So in parallel. So bank note classification exercise.
And so one of the many advantages I noticed as an individual is that the processing the whole processing takes part in the cloud. So none of the processing is actually dependent on how much GB your RAM is or the the requirements of your PC. So that's a great advantage to have. So
Yeah, of course. So I don't have any image right now, but yeah, just I can make it just publicly available if anybody want to use. Maybe later on I can publish it in a better way. So see, this is I'm published to the gallery. If you want to refer the same one, or you want to copy it on your experiment and use it. Okay.
also.
Hi, sir. So Salil here once again. So
Hi,
the
Salil.
question is, you used two models while interpreting the data or analyzing the data. One is logistic and one is neural network.
Mm.
So how is it feasible to check or to analyze a particular data set by using more than two or more than three? I mean to say multiple models. Is
Yeah.
it quite correct to use multiple models? I mean, n number of models at the same time?
See that's why. See what happens is, as I mentioned, not a single model works perfectly on the data, right? So you take example, right? You have a multi-class problem where maybe some of the class, right, 0, 1, 2, 3, 4, 5, 6, 6 classes. Maybe one model is able to predict correctly the 5 classes. One class is not able to predict correctly, but another model, the 6th class, is able to predict very well, right? Because of the maybe complexity. This is the gallery where I publish this for your reference. You can use, and right. So in that case, it is good to use both the model in combination, right? To learn multiple features, right? Or multiple characteristics. So that's why random forest is one of the model. Here it will be decision forest or decision jungle, which are very, very popular, because that is basically a multiple trees, right? It's multiple models. So it is always correct to use, or maybe not correct, but better good practice to use ensemble model for better performance. But also keep in mind, when you have very small data or something, and you need to serve certain purpose, you getting good accuracies, you don't have to really develop another model. You can go with one model. If you see, typically a lot of pre-processing, a lot of time we have not done here. Feature engineering you have to do, binning, classification, and all of this, right? So it's not about only the model. So the feature engineering, the data processing, that would be also important. So I think I would say around 80% of the time you should be spending on data processing. I have skipped that, but 80% of the time you should be spending your feature engineering and data processing to understand the properties and the data and all of this. Okay.
Yes, sir. And we have our next session on feature selection and extraction. So
That
the
would be.
participants will get an idea about that.
Yeah, so I have not touched here. So there are some option here, feature selection, filter based, and all of this that you can bring in here, and like you can do something. Okay.
Hello, sir. So
Yeah.
you said that when we analyze the results and we see that the result is quite, is having a good score, right? Or is predicting in a good way, right? Or is having a good predicting rate.
Mm,
As a data analyst, for example, a data analyst asks the questions to the stakeholders or to the investors, right? That what
mm,
is the definition of your success as per you? So
mm,
the investor defines that 73% above or 85% or anything. But as a data scientist, we do not get the opportunity to ask such questions because we get a raw data and we have to find the questions and the answers as well. So how can a data scientist evaluate and or interpret that what is the success rate or the success definition of this particular data set?
Okay. So for data scientist, what we do is basically, firstly, slowly you should learn the business also. That's what I do from like even from early stage of my career. So you want to understand the business that you're working for, so that you have some kind of idea at least. Okay. The second is, I'll take example of credit risk scorecard, right? In your portfolio default rate is 10%, and your model is not able to predict that correctly, right? Then definitely that is not a success criteria. But also there could be other criteria that you need to look at. For example, it's called cost benefit analysis or profitability analysis that you would be looking at, right? By implementing this model, how much leap that you are getting from without having a existing model or no model, right? So how much additional benefit you are getting from that, or in terms of any cost saving that you do if you implement the model like the cutoff analysis, something called gain stable, right, in classification model. So if you can do that, like case, Gini, lot of other parameters that you can look at. It's called gain stable. I'm sure you will get here. Let me check. Right, after you score them, then you can understand this gain and leap and all of this, and then you can take that, right? Yeah, so these are some like Gini, leap chart. All of these needs to be looked at, not only the accuracies, that the main thing that you do in the business, and then you would be able to see, okay, this is the best model, this is the best cutoff, and all of this. Okay. Other way to look at is if it is a totally new business, you can do a test control champion challenger, implement the model maybe randomly on 20-25%, and then collect the performance for a few months, and then see if that is working better before you roll out for entire portfolio. Okay. Such like
Yes.
these leap chart, gain charts, and all of these similar to ROC. Case Kolmogorov-Smirnov statistics used for the separation power. It's not about accuracy, but separation power you look at, Gini you look at, then rank ordering you look at, right? Rank ordering means like higher probability with, for example, default case we take, right? Higher the probability, lower the default, right? So good prediction if you want to predict good customer. So that order is maintained. All of these you should look at. Okay.
Right, sir. So thank you, sir.
No problem.
Thanks a lot, sir. This was really an enlightening experience for all of us, and it was really very helpful for us as to understand how machine learning and data science is actually implemented and understood in the corporate sector and is worked upon. So thanks a lot, sir, to share your knowledge with all of us, and thanks a lot, sir.
Thank you everyone for being very good audience. There is a good blog. It's UCAN Analytics. One of the analytics professional, he writes. So there are a lot of business use cases there. So you guys can look at. And again, thank you for listening to me. Wishing you all the best. I'm available for any question answer. Okay. Take care and stay safe.
Thank you,
Thank you,
sir.
Ariful.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
So I'm stopping the recording right now.